Hello, organizers. Good afternoon. Organizers, good afternoon. Is it audible?
Yes, ma'am. It's audible.
Check பண்ணுங்க. Hello, madam.
Good afternoon, Selvi ma'am. It's
Madam, is it
audible.
audible?
It's
Yes,
audible.
ma'am.
Okay. I'll just share the screen. So just check it is okay or not.
To 6 or 8? 2 to 8. 3 sessions.
Is the screen is visible? Please
Yes, ma'am.
kindly let me know if the screen is visible.
Yes, ma'am. It's visible.
Yes, ma'am, it is visible. Shall we wait for another 2 or 3 minutes, ma'am? Hello. Salvi, ma'am.
Okay, ma'am. Thanks. I have received it.
Salvi, ma'am, can we wait for another 3 minutes?
So I'll just mute it now.
Okay.
So when we are about to start, we can I'll unmute it and make my presentation.
Okay, ma'am, I'll be informing you.
Is it okay, organizers?
Yeah, good afternoon to all the participants present over here and all the resource persons for today's sessions. Myself, Dr. Kiran GM, working as an associate professor in the Department of Computer Science and Engineering, Sridevi Institute of Engineering and Technology. I would like to welcome all the participants as well as the speaker of today's session to this last final day. So we started from Monday and we are to the end of this day. So I would like to thank once again all the speakers who delivered their speech very well from day one till date. So today we have with us Dr. S.S.L.V., Associate Professor and Head of the Department of Artificial Intelligence and Data Science, Kangayam Institute of Technology, Tamil Nadu. So in order to enhance the technical skills of all the faculty members and the students, our department, Computer Science and Engineering, Sridevi Institute of Engineering and Technology has been organizing various webinars, faculty development program recently and frequently. In this direction, so this FDP, which has been sponsored by ATAL, organized by the Department of Computer Science and Engineering, Sridevi Institute of Engineering and Technology, will be enabling the participants to know what are the various techniques that are there in quantum technologies to implement or to know the concept or what can be done by using these concepts. So in this direction, today we have with us the three speakers. So it will be starting from 2 p.m. that is right now. So the first session will be handled by Dr. S. Salvi and the second session will be handled by Dr. Rakesh L. And finally, the last session will be handled by Karthik Ganesh. So finally, around 6:30 to 7:30, we will be having an online test. So where all the participants are requested to take the test, where the marks will be evaluated for 30 marks. 30 questions will be there and it will be evaluated for 30 marks. So attendance was mandatory. All the peoples are attending. So it is good from the participant wise. Salve ma'am? Salve ma'am?
Sir, is it audible, sir?
Yes, ma'am, audible, ma'am. Can you start, ma'am?
Yeah.
Okay, ma'am. Once
Sir,
again,
the
welcome
screen is
Dr.
also
Salvi, ma'am.
visible so that I can.
Yes, ma'am, it is visible.
The screen is visible, sir. Shall
Yes,
we
ma'am, it
start?
is visible. Yeah,
Okay.
ma'am, you can start.
Okay. So before I start the session, let me thank once again the organizers of Sridevi Institute of Engineering and Technology for giving me another session to share my views apart from my academics. So this is based on curriculum mapping and accreditation perspectives. So in this I would like to share whatever the practices we are following in our college for NAC and NBA. So if it is accreditation, the college will be aiming on two aspects. One is NAC, the other one is NBA. So both based on these two accreditations, what we the college we are following. So that I would like to share few informations. So I hope those will be useful to you. So let me share. So before I'm going to the session, uh, I would like to give you some challenges in 21st century education. So because based on the challenges in 21st century and the Gen Z students, so we are incorporating continuous changes in the curriculum, academic and accreditation and everything. So right from NBA, right from its initiative routing from there till now. So the NBA criteria, the NAC criteria are keeping on updating, and they are totally concentrating on the practical exposures and the outcome of each and every aspect of the programs and academics, what are all being practiced in the college every day. Okay, so there are certain challenges what what the academic institution, that is educational institution, are facing. A few such aspects are how to improve the students' engagement, because I have said you already, it's the Gen Z students. So how to engage all the students in an effective manner in the lecture class. The second one is how to improvise the students' knowledge, their skills, and particularly attitude. So the students' attitude towards studying and students towards improving their technical skills based on the cutting edge technologies, and how to allow the continuous improvement. So that is based on the cutting edge technologies, and how to that we can reflect the knowledge, skills, and attitudes. Those things we can achieve only by having a continuous improvement in curriculum, and to have an open educational resources and with more effective teaching. And how to ensure the examination system. So the total examination system is reinforcing the teaching learning process, because at the end of the teaching learning process, it continuously reflects the examination system. The examination system is not, I'm not meaning with continuous assessment, monthly test, or you'll be saying some internal test or end semester examinations. So each and every practices, what are all we are following within the in the college, so that we can say is the teaching learning process. Those things, everything will be examination, everything will be validated. Next, how to ensure the lifelong learning. Sir, is it organizers? Is it audible?
Yes, ma'am, it is audible. Ma'am?
Is it audible?
Survey, ma'am? Yes, ma'am, it is audible.
Pardon?
Yes, ma'am, it is audible.
Okay.
Okay, ma'am, okay.
Okay. Coming back to the slides. What are the questions that arises for an engineering education? Because why we are going for engineering education? So it's a professional degrees. So what is a full set of knowledge, skills, and attitudes, and their level of proficiency for a student should be developed as they graduate from the institute. So once they graduate from any institute, so what is the knowledge, skills, and attitudes, and the proficiency level students can acquire once they get graduated from an institute. So for those things will be rectified, or will be accompanied or guided by engineering accreditation process, outcome-based education, active participation of industry for defining the outcome of education. So these three are there. Next, how do we ensure the students develop and acquire those skills? How do we ensure it? So by using some suitable pedagogical methodologies to define the outcomes, valid and reliable assessment and evaluation process, and resources, what are all the resources shared by the industry. That resource can be anything. So it can be human resources, or it can be a portal resources. Some resources, what are some tools and techniques, what are all the students are industry is practicing, the industrial persons are practicing. So that could be reflected in the curriculum, and also it can be practiced by the students. So as I have said you, the NAC and NBA process. So the NBA accreditation. So these accreditation, it should not be in a documented manner. So these should be in a process. It should be in a everyday process. It should be inculcated and incorporated in our daily curriculum and in our college educational process. So it is not a documentation. It is not a It is purely a process. So what are all the process, or what are all the things we are following in the curriculum, or in the teaching learning methodologies, or in assessment and evaluation? So that will be documented and produced to the NBA and for NAC. So the outcome based education, so it addresses the following questions. So what do you want the students to be able to do? So this outcome based education is nothing but, after a particular course being studied by the student, what the knowledge set or skill set will be acquired by the students. Because this outcome based education is purely based on the student centric. The second one, how can you help the students to achieve it? It is not a conventional teaching methodology. So it is purely their teaching to the students. So good.
Salvi ma'am. Okay, I hope there is some network issue. I request all the participants to stay online. I'll be connecting ma'am as soon as possible. Salvi ma'am. Ma'am, is it audible to you?
Yes, sir, audible.
Salvi ma'am.
Silver has muted.
Okay,
Is it
just a minute,
audible,
I'll be
ma'am,
calling
now?
to. Yes, ma'am, it is audible. I hope you are muted for yourself, ma'am.
Yeah, shall I continue?
Yes, ma'am, you can continue, ma'am.
Oh. Okay. How do you close the loop? So the total thing will be closed only when the evaluation system is being reinforced. Reinforces to the teaching learning process. So the outcome based education, so it is not only, it is purely for outcome based accreditation, because the accreditation NAC, NBA, everything is purely based on outcome based accreditation. So outcome based education, in turn, you have to reflect the outcome based curriculum. You have to inculcate the education process in the curriculum. You have to inculcate the outcome based learning in the teaching process, and you have to inculcate the outcome based education in the assessment process also. So what the students should be able to do at the end of, or after completing their course, or how far it is implemented in the curriculum, and how far the faculty members are following, are adapting new teaching methodologies to facilitate the students to be more interesting, to make them more interesting, and how far it is being assessed, everything. So the teaching learning process. So this is also one of the important part. So which will reach the outcome based education. So you have to promote the self learning. So it is not like a book bag. So whatever the students, right from school, they are schooling, they are coming to the college life. So they are thinking as like it should not be similar to a schooling life. So because there will be only book, and book it will be replicated in the exam, and you're getting scores, and based on that the students are measured. Whereas in college, particularly in engineering education, so it should be totally eliminated. So it should be, you have to promote the self learning process other than academic and curriculum. So you have to promote the self learning process, and the students has to work in groups to develop projects, and there should be continuous improvement in the curriculum based on the suggestions from experts from industry, from academia, from parents. So they are the stakeholders, from the students too. So students are knowing much more than us also. So in few aspects, not all aspects, from few aspects. So we can get from them also, them from alumni. So there are more important stakeholders based on from whom we can get suggestions. And next, so frequent training to the faculty members, because the faculty members has to be trained well in cutting edge technologies also, and also in teaching learning process also. So they have to be so they should not follow some conventional teaching methodologies. And how far the students will be evaluated using more scientific approach. Scientific approaches is AI is everywhere now. Okay, so now we have to evaluate the students in by using some AI tools or something, so that it will be more interactive for them, more interactive and fascinatable for the students to be more involved in evaluation. Sorry, in attending the assessments, because only when the students are attending the assessments properly, so that will be reflected in the evaluation procedures, and the skill sets will be very much what it is. It will be very much reflected. Okay, so the students will be fascinated first. So for fascinating the students, it has to be more interactable. So for interaction, the AI will be a very good guide. For example, for outcome-based education, so if you provided a carpenter has to build a table, so simply building a table is not it is not an easy manner. So you have to make it in a smart manner. So it has to be in a outcome-based approach. So he has to have some picture in mind. So how to build a table, and what are all the materials he has to use to build the table. Okay, and what are the step-by-step procedures he has to follow until he is building a table. So similarly, if a mother has to want to cook a meal, so he has to first has to put in mind what type of meal he has to prepare, and the image should be revolving into the mind of the mother. So the dishes should be how to look like, how it should be tasted, and everything. And based on that, he has to assemble all the materials and everything. Okay, and I had to make a step-by-step process. Then OBE should process on the student learning, the outcome statements. So that I'll come with later. So the OBE should be specific, it should be measurable, it should be achievable, relevant, and time-bound. So it should follow the SMART-based approach. Next, it providing the learning activities which will help the students to reach these outcomes, and you have to perform the as usual assessments. Some using some explicit attainment tools. So there are some attainment tools also available. Okay. Next, National Board of Accreditation. So if you might know about it. So just as a formality, I'll give you just an introduction slide about it. So the Washington Accord. So this is the root for NBA. So it is an international agreement among the bodies, so which they are purely responsible for accrediting the undergraduate engineering degree program. Okay, a minute. 1 minute, I'm getting a call, please. Okay. So MBA was established in by AICTE in the year 1994, and it is operated as an autonomous body since 2020. And India is an officially as a member of Washington Accord, so that only the Indian universities and Indian colleges are we are fighting towards attaining the OBE through MBA process. And Indian universities and institutions, they are rising to the standards, to that standards. So only when the criteria are being satisfied by a particular college, so that particular Indian university institutions, they will be raised to the international standards. And one more thing is the students who are all getting graduated from an NBA college, from an NBA accredited program and a particular college, so they will be easily recognizable, and their degrees are being acceptable by any foreign countries. So that is one main aspect why the colleges are going are satisfying the NBA criteria. Okay. Next. So if you might have know about the programming outcomes, that is learning outcomes, you can say is a program outcomes. So initially, or in the previously, there are 12 program outcomes or learning outcomes, and now it has been changed into 11 POs. So the first PO is engineering education knowledge, problem analysis, design and development of solutions, investigations, and let me explain everything. Modern tool usage. Okay. So these five are domain dependent or program dependent program outcomes. Okay, so you can divide the program outcomes, 11 outcomes into domain dependent and domain independent. So if it is domain independent, you can come with the first five outcomes. That is engineering knowledge. So engineering knowledge is you can apply for the knowledge of mathematics, science, engineering fundamentals, and some specializations. So to solve the complex engineering problems. Next to problem analysis. So the problem analysis, what are all the subjects or what are all the courses you can identify which can be being taught to the students so that this PO can be matched. So that is called based on the concept of mathematics, natural sciences, engineering sciences. For example, you can go with engineering mathematics 1, 2, programming languages, some statistics for data science, and similarly. So since I belongs to ABS, I'll just give an example based on that. Statistics for data science, fundamentals of data science and analytics, data analytics using R. So these are all some courses which can be being taught, which will be used, and this outcome can be achieved. And design and development of solutions. So design and development, so the students can be able to design for a given problem statement. The students can be able to design some solutions or come with the solutions. So based on the subjects what are all he is being taught, and that solution should be useful for the purely for the society and for the environment. Okay, and it should be focused on public health, safety, and societal issues, everything. Next, investigations. Investigations is you can perform some analysis, and you can use some data. When you're implementing and when you're developing a project, so that project has to be exercised or implemented by using some data. Without data, you couldn't say the particular project is being properly validated or verified or not. Okay, so for doing a project, you are in need of some data. So you can interpret the data based on the problem statement and everything. So I'll come. So these POs, everything are student centered. So the student should be able to achieve all these program outcomes. So then only he'll be able to be a graduate. So he is a better graduate when he is coming out of the industry. Sorry, from out of the institute. So and also I can remind you that all these POs cannot be satisfied by a single course. So few COs, that is few courses or few subjects will satisfy few program outcomes, and few POs may not be satisfying. Okay, so the program outcomes, all these 11 program outcomes will be scattered across what are all the subjects we are studying right from semester 1 to semester 8 throughout the curriculum. Okay, next, modern tool usage. So I have said you the students has to be updated regularly, and the students has to do some projects, and they has to be able to design some solutions for a given problem. And those designed solutions, those logical reasonings and everything has to be implemented by using some tools. Okay, so for this tools, you are need of some software. The student should be able to learn some tools. For example, for Python, you can go with Jupyter Notebook, or for Anaconda, or you can go with some. If you, I'm saying with based on AI based. So if a particular student has to be able to has to do some machine learning project, so he should be able to use some tools, automated tools like Jupyter, some automated tools like BigML, Orange, Rapid Miner. So these tools he should be able to know. And if a student has to become a full stack engineer, he should be able to learn about the Java totally, and Eclipse IDE, NetBeans. So these are some tools which the student should be mastered. Okay, next, engineering and the world. So right from the program outcome 6 to 11, everything is domain independent. Okay, so here also few subjects will be scattered across all these POs, engineering and the world. That is, you have to apply that contextual knowledge or what are all the knowledge you have acquired from the course, from a particular course, that should be relevant to the professional engineering practice, and it should be some environmental based and from sustainability. Now, for example, if a particular project has been a student is building or developing a biometric system. So that biometric system should be sustainable and prolonged in usage. So it should be prolonged. So the lifetime or validity of that particular project should be in a prolonged manner. So the validity should not be very short duration, right? So that based on that, the sixth PO, next ethics. So for all the projects and what are all the projects or what are all the studying the student is undergoing, so they everything should follow ethics. Okay, so that is ethics. So even AICTE and UGC are suggesting some ethics paper, human values paper, universal human values paper, professional ethics, AA ethics is there, safe and responsible AA is there. So these are all some ethics papers. So which graduates should learn. Even AA ethics in AA should be learned by any core disciplines. So irrespective of all the branches, all the students should learn about ethics, in particularly AA also, because uh, um, it is now in standard, it is in usage now. A next, individual and teamwork. So when the student when a graduate, you can say a graduate will be a student will be transformed to a graduate only when he is completing his 4 years degree course, right? So a graduate, when he is going out of the institute and he is being employed in a particular company, he should be able to work in as an individual and also as a teamwork, as a team. So for that, some project based from many
Salvi ma'am? Salvi ma'am, the voice is muted. Salvi ma'am, am I audible to you? Okay, you hope due to some network issues, the ma'am is not able to connect. Okay, I request all the participants to stay online. Within a fraction of 4 minutes, ma'am will be back.
Okay, I'll continue.
Yes, ma'am. Please, ma'am.
Okay. So next, communications. This is the communications. You can introduce certain courses. That is, the student, even though he is more technically sounded, he should be able to communicate it, right? So he should communicate it. The industry people are not at all expecting some very good hi-fi English. Okay, so they are expecting a simple English, so which where the students' thought can be communicated to the opponent. So okay, so one minute. So next, project management and finance.
No, ma'am. It is showing 21st century program
So
only.
project management and finance. So
No, ma'am. It is
project
showing learning
management
outcomes.
finance. So this also will come with the project work and mini projects and everything. So the student should be able to complete the project and implement the project with a given budget and everything is there. And he should be able to work in multidisciplinary environment. That is, a civil or ECE people can be able to work with an AA student because AA has been inculcated in everything. Just an example. Okay, so the civil student and an engineer and our A student can work together to do a project. So these are all the things the NBA and NAC are expecting how far the students are doing projects with an interdisciplinary domain. Okay, next, lifelong learning. So an engineering graduate should be a lifelong learner. He should be adapted to the new technologies and everything. Okay. So next, what is the program structure of a 21st century? So it starts with vision and mission of an institute. Okay, so your institute should have a clear vision and a clear mission. And so based on that vision mission, the program educational objectives should be framed. And based on the program educational objective, I'll come with the one by one everything. And based on the program educational objectives, okay, so to attain the program educational objectives, the program outcomes and the program specific outcomes will guide, will help to attain the PEOs. Okay, then how the program outcomes and the program specific outcomes will be attained only through courses, only through each and every courses. The students will be roughly studying approximately 45 to 50 courses throughout the 4 years of duration, right? So each and every course will be carrying a course outcome. So at the end of every courses, the student should be able to do something, should acquire something, should be able to implement something, should be able to apply the concepts what are all being studied in the syllabus to the real world, to some applications and everything. So based on that, the program outcome and PSO will be attained, and based on the PO and PSO, program educational objective will be attained. And when program educational objectives totally attained, the vision and the mission will be satisfied. The mission and vision of the institution will be satisfied. And this is a total OBE framework. So what we are following in our college. Okay. So it's mostly same in all the colleges or in all the institutes, but there will be some slight modifications based on the structure, administrative structure. Okay, so here I have said you vision, mission, PEO, PSO. So this, when you're coming with this course, program, and institution, so this will be framing based on the curriculum and also from the input and feedback from the stakeholders. So the stakeholders can be a student, an alumni, a parent, an industry, okay, even a final year student, even a first year student. So everything, so all our stakeholders, we have to get frequency. There are certain frequency, and through some statutory bodies, you can get all these feedbacks, and you have to record it everything, either through online or through some paper based work. You have to record it everything, and based on the feedback, you have to reflect everything in the vision, mission, PEO, program outcome, course outcomes, everything. Whereas when I'm coming with vision and mission for the institute, and for the institute, it may vary based on for institute to institute, the vision and mission vary, because certain institutes may be in rural colleges, certain may be in urban colleges. So if it is a rural colleges, mostly rural students will be coming and joining the college. So based on that, their vision mission gets changed. And when you're coming with urban colleges, there it will be total. The students will be, everyone will be somewhat ultra modern, and every ambience will, that particular institute will be provided with all the ambience what are all being required. Okay, so that vision and mission will be changes, and uh, so based on that PO, CO, everything will be all the teaching methodologies you're going to apply. For example, not only a PPT slide, is not like a PPT slide and everything. It may be some spoken tutorial, it may be self-learning, and it may be some activity-based learning, experiential-based learning process, how far the students are learning. Okay. Next, assessment and evaluation. So what are all the students are acquiring. So we have said you course outcomes. Those course outcomes, we are saying the students will be able to apply this, he'll be able to do the projects and everything is there. Okay, how it is being evaluated. So the outcome of the each and every process should be assessed. Process will be totally regulated by a particular cell called internal quality assurance cell, and this cell should be established in each and every college. So almost all the colleges will be having an IQSS cell. If any of the colleges not has been implemented, it should be immediately implemented. Okay. So vision, mission, and everything. So what we have followed, what in our college, in the Kongam Institute of Technology, what we are following, mostly many colleges will be following this. So vision, mission, and program. So based on the vision, mission, and mission of the institute, the departments, that is the programs, BTech degree program, BE degree programs. So those are BE, CE, BE Triple E, BE Mechanical, BTech ADS, BE CSE. So these are all the programs we'll be saying as programs. So each and every program, they have to draft a vision, mission, and a program educational objectives. Okay. So next one, the for this, you should need this should be need a department drafting committee. You have to frame a department drafting committee, and in that you have to include the stakeholders also, and you have to get the suggestions from internal stakeholders, external stakeholders, and everyone. Okay, so based on that, after that vision, mission, everything what you have drafted, that has to be forwarded to the department advisory committee for approval. Okay, so after that, constituting, you have to constitute a department advisory committee. You have to constitute a department drafting committee. Okay, so for a department drafting committee, it can be the committee can be comprised of head of the department and senior faculty members of the department. Okay, next is some experienced persons, and for DAC, that is department advisory committee. So surely the comprises of head of the department, senior faculty members. No need to add all the faculty members. So just the senior faculty members. Next, external expert, academic expert, industry expert, an alumni nominee from student, a nominee from stakeholders, nearly a parent. So parent feedback also we have to, it's also very must. Okay, so everything should be so there's a frequency there. So frequency of this meeting, it may be a 6 months once, or a few colleges may they conduct a 1 month, 1 year, yearly once. So we now in our college we'll be DAC has been conducted every year, once in every year, and department drafting committee, that also in once in every year will be. So after everything, after completing everything, after modifications, everything, we have to get the approval from the academic audit. So here I have said you, based on this, there are two types of colleges: Tier 1 colleges and Tier 2 colleges. Tier 1 colleges, maybe some autonomous colleges, and Tier 2 colleges, some affiliated colleges. Okay, so this is this structure, this flow chart is based on the Tier 2 colleges. So here only governing council is there, but for an autonomous institution, you have to get the approval, recommendations, and suggestions from after department advisory committee. You have to get the recommendations from board of studies, and after board of studies, we have to pass over to academic council meeting. And today also we have I was in the middle of the academic council meeting. I was left out and came here. Okay, so academic council meeting, and after that you have to ratify the same to the governing council. So in autonomous colleges, we'll be saying as governing body. Okay, so I have to get the approval from governing body. So in governing body, there will be a group of trust peoples where management peoples will be involved in that. Okay, governing body, and after everything, after getting approval from everyone, so you have to publish it in websites, in your log books, in your record notes. Everywhere you have to publish it. Okay, in notice boards, everywhere you have to publish it, and you have to teach the students about the importance of vision, mission, what is your program vision, what is the program mission, what is the program educational objective, what is program outcome, what is outcome based education, what is course outcome, how you will be attaining everything. You have to make the students to be more exposed to that. So vision, how a vision has to be, vision mission has to be framed. Okay, so the vision is a futuristic statement. Other than okay. Is it? So the vision statement is a futuristic statement that the institution should, I would like to achieve over a long period of time. And mission is the means by which it proposes to move towards stated vision. That is, the vision and the mission should be aligned. So the mission should be aligned with the vision. So the vision can be achieved only through missions. The mission has to be aligned. So it is similar to a mission is like a milestone, and vision is like a destination. Okay. Program educational objectives. So the program educational objectives is nothing but a graduate, after he's graduated from the institute, from an institute, after few years after graduation, what the particular graduate will be look like, what he will be achieved after few years, we say 4 years. Okay, so after 4 years of completing his degree, that is completing 4 years, and after 4 years completing degree, and the next four more years. Okay, so after that, what the student will be look like, and we have to assess those students also. Okay, so you have to assess that you will be saying as graduates, so you have to assess the performance of the graduates, you have to assess the current scenario of the graduate, what is he look like, what is his designated post now, and similar things. So for this, we have to get feedback from employers that the particular graduate is working on. So based on that, you can assess how far the PUs has been achieved. Okay, the POs can be guided by global, local leads, vision of the institution, long-term goals. Everything should be incorporated. These all things has to be kept in mind while you're designing PUs. So your program, a branch will be assessed based on vision, mission, PU, PSO, and PO is naturally you are getting from NBE. Okay, so how far your vision and mission are more suitable, more specific, and based on that, the department progress will be easily measured by the expert teams. Okay, so from local employers, from industry, student, alumni, so the everything, every feedback has to be taken into account. It has to be incorporated, and it has to be as a statement as a PO. Okay. Next, POs. So POs, I have already explained you. So those POs has been defined by the accreditation agencies like NB in India, and POs are the starting points, and POs are learning centric, learner centric, that is student centric. These students, what they will be after the particular degree, after
Yeah, request all the participants again to stay. Since there is a network issue over there, I'm requesting madam to again relog in it. Thank you. There is some network issues in the, so I request all the participants to stay online. So ma'am will be again joining in another 2 minutes. So I thank all the participants to stay online.
Okay, is it audible?
Yes, ma'am, it is audible now. You can please continue, ma'am.
Okay, sir. Madam. Okay. So next it's program outcomes. So the program outcomes, what I said, uh, when all the 40 to 45, the students are learning nearly 45 to 50 subjects. So when all each and every subject is contributing its to the POs. Okay. So after completing all the courses, the student will be able to acquire all the POs right from 1 to 11 and also with program specific outcomes. Okay. So கொஞ்ச நேரம் இருங்க என்னன்னா இதாயிட்டே டிஸ்கனெக்ட் ஆயிட்டே இருக்கு சில டைம் சரி. So next it's course outcomes. So the course outcomes, each course is designed for about 6 course outcomes. Each course is having at least 6 course outcomes. At minimum, they are having 5 course outcomes for unit wise. So initially, on the earlier days, and many of the colleges also now also they are practicing with 5 course outcomes. Specifically, each subject will be having 5 units, and for each unit they will be having a specific course outcome, right? And consolidating all the 5 course outcomes, there will be a sixth course outcome. So consolidation of all the 5 courses of course outcomes from CO 1 to 5. So there will be a sixth course outcome. So this is one category. And one more thing, now this is somewhat okay method. Whereas when you're coming to the second one, which is a difficult method, that is what I'm going to try to say is when there are 5 units, so incorporating, considering all the 5 units, what will be the what the students will be able to acquire at the knowledge level. So this will be the course outcome. Next, CO2, it can be the consolidating all the 5 units. What will be the students will be able to acquire at the apply level. Next, or acquire similarly at the understanding level, at the creating level, at the evaluating level. So they're consolidating everything. But this is being practiced in few colleges, but it is very difficult to frame the course outcomes. Okay, so that is a little bit difficult. Okay, so the POs are attained through program specific core courses also. The course outcomes are stated in such a way that they can be actually measured. Everything should be measured. I'll show you an example of this also. So I have said you smart, that it should be specific, measurable, attainable, everything, so it should be measured, and the POs are attained through program specific courses also, because the program outcome is being framed by NDA, whereas program specific specific outcomes, so that has been framed by the departments or by the programs. For example, for ADS, we have our own program specific outcomes. So that can be minimal. It can be specific outcomes or 3 specific outcomes. Okay. Next, so it is one example. It is not a good example. For example, engineering physics, everything is understandable. That is, you can keep in mind that the course outcome should be learner centric. I have said you preview is learner centric. Similarly, the course outcome is learner centric. Then you can ask a question: what is course objective? Right? The course outcome can be a teacher centric. What is the teacher is going to teach for a particular course, so that can be a course objective. The objective can be a teacher centric, whereas when you're coming with the course outcome and the program outcome, that should be a student centric or should be a program that is learner centric. So at the end of course, studying that particular course, the students will be what they will be able to achieve. So this is a good, not a good example, it's a bad example for a course outcome. So the success of outcome based education gets initiated from framing how far you are good in framing course outcome. So if you are making many mistakes, if you are not totally involved in framing a good course outcome, the outcome based education will be collapsed. You will not be the course outcome will not being framed in a good manner, in a more measurable manner. You will not be able to evaluate it, you will not be able to assess it, and you will not be able to attain it, and finally the program outcome, everything will be collapsed. Okay, so this everything is an understand level. So this is a teacher centric, and so it is not a learner centric. Understand level is not a learner centric. Understanding the knowledge of basic quantum mechanics, understanding the fundamental, understand the role, understanding basic, understanding theory of free, so and so is there, no? So these are everything is understand level, and how you'll measure it, you will not be able to measure the understand level, right? And this is not a good example. Okay, I'll come with a good example, or this is I'll come with a good example later. Okay, so these are some Bloom's revised taxonomy based on which you have to frame the course outcomes. Okay, remembering, understanding. So these two, I'll suggest you that the remembering the course outcome should not be at the remember level. Okay, understanding level, it can be one. It may be one, and if it is not now, it is good. Your course outcome can start from applying level. Okay, applying level, analyzing level, evaluating level. For as far as for UG programs, the creating level, you can discard it. You can discard the creating level. It can be very very, for project based courses you can use that creating level. Okay, but for you can restrain to applying, analyzing, and evaluating. Okay, so there are certain things here. Remembering, recalling the informations, everything. So due to time limit, I'll just pass with the next slide. Remembering level. So you see here program outcomes. The program outcomes will be reflecting the course outcomes. From it will be extracted from the course outcomes. So remember level and understand level, you can restrict it. You no need to frame the course outcomes by using remember level and understand level, but you can. It is the course outcome is open to apply level, analyze level, and evaluate level. Okay, so the apply level can be mapped with the engineering knowledge, and analyze level can be mapped with the PO2, that is problem analysis, and for evaluate level, you can map with the program outcome of three, that is the design and development of solutions. And so these are a few examples. Okay, so you cannot restrict the analyze level with PO2 alone. You cannot restrict the apply level with the PO3, PO1 alone. So this is one example where it can be mapped. So these are direct mapping. Okay. Next, the course outcome should be broken down into two main components. One is action word, then is one is the learning outcome. Okay, so the good action words for a course outcome should be compile, identify, create, plan, revise, analyze, design, select, use, prepare. So these are all certain action words which must be used for a course outcome. Okay, so I have said, I'll repeat it once again. The course outcome is very prominent start for an OBE, and it should has two parts. It should have two parts. One is action word. The second one is the learning statement. This is one of the example course outcome. What we have framed for a subject called problem solving and Python programming. SIBO 1, develop simple computational problems using Python operators and control flow statements. Even in our college, we are following unit-based course outcome only. So I have framed with it based on that. The course 1, it is your developing. That is at the end of studying the unit 1, what the student will be able to do. So here I have given you, at the end of this course, the students will be able to, I have said, so what will be the students will be able to do? He will be able to develop simple computational problems using Python operators and control flow statements. So that the unit 1 will be having uh, topics based on Python operators, Python introductions, Python control flow statements, and everything. Next course outcome 2, using functions, list, and string operations in Python, with and without building functions, how he'll be able to use it in his program. Okay, next course outcome 3. It's applying. So how will you apply the properties of tuples and dictionaries in Python for a particular few examples? Next, how will you design the Python code to explore the file operations? Implement the object-oriented concepts in Python programs. So our fifth unit is based on OOP concept in Python. So we have given us implement the object-oriented concepts in Python programs. Okay. Next, CO-PO relationship. I have explained you now itself, the CO and PO. So each CO can be identified to address a subset of POs. So not all the POs will be matched with the COs. Each CO, each and every CO will be identified or mapped with the PO. Okay, next, based on the number of COs and sessions what we are dedicating, it is possible to identify strength of mapping. So now I have said you, we can identify the mappings of CO and PO. The second one is you can identify what type of strength of mapping between that particular CO and PO. Okay, next, what is the strength? So for that, you will be having a PO, CO, CO, PO matrix. So this is one example for the same Python programming we have did it here. This is a theory subject. For this theory subject, how we have mapped it. So for the CO1, it is mapped with the program engineering knowledge, problem analysis, design and development of solutions, investigations, modern tool usage, and PO10 teamwork and lifelong learning. Okay, so here I have said is strength. There are three strengths, three contributions. That is low level, medium level, and high level. Mm, so any always the course has to be mapped with the POs with two levels. You just have in mind, but it's medium level and high level. If it is mapping with the low level one, so that the syllabus is not being framed in a proper manner. You can identify in such a manner. You ensure that for each and every PO, it has been mapped with 2 and 3 at most, with mostly. Okay, so one you can eliminate it totally, because if one is by being mapped, the syllabus is not being framed properly. So because the syllabus is framed to make the students to learn something at the end of the course, and that course has to be mapped with the program outcome, then you have anyway you have to map with the program outcome. Then why how it is possible to map with the lower level? So it should be mapped with the medium level or with the higher correlation level. There can be no correlation. That is because I can say you that this Python programming cannot be mapped with uh, ethics and everything you couldn't say. Okay, so so to what are all the POs it has been mapped? It has been mapped with either 2 or 3. So this is my suggestion, because the mapping level, this matrix, articulation matrix, everything varies from person, faculty to faculty. Okay, so but these are some guidelines you can have in mind while you're framing your COs, POs, and everything. Okay, so this is one rubrics what we have followed for CO attainment. Okay, attainment level. So this is for a particular batch or for a particular batch of students. You have to frame the attainment levels, and these attainment levels has to be. So once again. So I'll just attend the call, please.
Hello, ma. Oh, Salvi, ma'am.
Okay.
Yes, ma'am, it is audible.
What I said here? Yeah. So this is for a particular batch of students. Level 1, level 2, level 3. So there are 3 levels we have to frame it for attainment levels, high level, moderate level, and low level. So for a particular batch of students, you have to frame the attainment levels. For that, it can be an outcome. That is, if it is level 1, you can see less than 60% of students scoring the attainment level of B plus grade, because in our college we are following the grade systems. Okay, so here I have showed you the range of marks, grade points, and everything. B plus grade. So if in a particular class, if there are 60% of students, and if it is less than 60% of students attain, that is they are scoring B plus grade, means they will be that particular subject will be attained with the level 1 attainment. Okay. Similarly, if the greater than 60% of students, that is 60 to 70% of the students are getting B plus grade in the final examination, then that particular batch has attained level 2 attainment. Similarly, after grade, there is if it is like more than 70% of the students are scoring B plus grade, then it will be level 3. So totally the third level, that is full attainment, the particular batch will be obtaining for the particular course. Okay. So then attainment levels. Attainment levels are level 1, level 2, same thing. It's for internal examinations also, you have to confirm this, and you may ensure that all these attainments has been framed and has been approved by the department advisory board and department advisory board. It's more than enough. Okay. Next, so how you'll assess the weightage of the SABO attainment? So by using internal assessment and external assessment. If it is an internal assessment, that will be that weightage will be 20% of the marks. That is, you have to convert the total 100 marks into 20% of weightage, and the external attainment level, out of all the 100 marks, you have to convert into 80% of weightage. Okay. Next. Um, so recently we have undergone MBA visit, and we have used the same what I am saying, same criteria, same parameters we have used to meet the POs. That is, apart from the academics, we have also used the programs, what are the programs, curriculum gaps. You can say curriculum gaps from the syllabus. So those curriculum gaps has been overruled or has been completed by using seminar, webinars, in-plan trainings, value-added courses, industrial visits, conferences, poster presentations, or some other events. So these are all some programs through which you can overlap the curriculum gaps with the syllabus. Okay. So these are also will be helped in attaining the POs. So you see here, this is a total assessment tools for PO and PSO. So direct assessment, indirect assessment. Direct assessment through course CO attainment, you will be getting the direct assessments. Course type, there is theory, practical, project. So what are all the assessment methodologies, what is being used, what is the frequency of assessment methods. If it is a theory, internal and external exam, in semester examination. If it is internal examination, it is thrice in a semester. Or two in a semester. Some colleges they'll be following 2 in a semester, and if it is a university examination, it will be once in a semester. And if it is a practical, model practical, and university practical. Okay. Next, once in a semester project, you'll be going with a sequence of reviews: 0th review, first review, second review, third review. So there's everything. Next, 501 that is the university examination. Next, surveys. So these are all some indirect assessments that that also will be helpful in attending the POs. Okay. Program exit survey, that you will be getting once in a year for a single batch. Program exit survey, alumni survey, employer survey. Next, students co-curricular activities. Students co-curricular activities is a measurable one, because based on the concepts what you are teaching in your class, based on that he'll be making some projects, and projects fast he'll be attending, he'll be acquiring some prizes, he'll be projecting those projects. That is a continuous activity. By using that also, you can measure the attainments. Okay. Next, this what we have followed for our NBA for criteria 3. These are some seminars and webinars I have said you in the previous slide. No, so for those seminars, webinars, to which PO it has been a map. How far it is mapped, how it is linked. Okay, so this everything, so uh, you have to make a map, and before that, for each and every seminar or for each and every program, you have to write on an objective course outcome. Everything should be written, should be why we are going for that objective, that is for that particular program, what at the end of the program, what the student to be able to achieve. So everything should be mapped with the program outcomes, right? So you have to write it, frame it properly, and you have to map it with. Okay. Next, value-added courses. So value-added courses is also one of the tool to map the curriculum gap. Okay. So here some what we have followed, what are the some few courses, what we have practiced, what we have inculcated as a value-added courses, that is Red Hat, Python programming, implant training, AR, VR, Microsoft Azure, full stack. So these are based on the industrial needs. We have framed some value-added courses. So these are some innovative teaching methodologies. Mm, Innovative teaching methodologies in the sense some innovative, that is this comes under teaching learning process. Okay, in teaching learning process, some flipped classroom teaching, blended learning, project based learning, gamification, experiential learning, collaborative, zigzag method. So these are few. Okay, so in this innovative teaching method you can go with flipped classroom teaching. Flipped classroom teaching is a sense, the student is given a topic, and we are making them to explain through some tools, through some presentations, through some presentations, or inside the class, inside during the lecture hours, we are making them to present it. And based on the presentation, we are asking questions to the students, and we are measuring that also outcome. So for each and you make ensure that for each and every innovative teaching methodology, you have to measure it, you have to assess it, you have to measure it, you have to evaluate it. Okay, next, blended learning. In our college, one of the best practices what we are following is, for example, we can take for a Python programming. For Python programming, we are having an MOU with a particular company, and with that company they are providing some portals, and our curriculum has been mapped with their portals, and the students are being learned through the portal the particular subjects. So it is similar to a practical based learning. Okay, so the students has to work out it. For example, for Python programming, for example, nearly 100 programs has been posted in the portal. Okay, it is similar to a lead code and hacker earth. Okay, so there are some websites. So based on that, a similar portal has been designed and provided by the industry persons, and the students are using that portal. And we can ensure that the students, if they are able to, so it is similar to a game like easy level, moderate level, and difficult level. So in all levels, the students will be able to face the programs, and the students will be provided with hidden test cases, and the students has to be able to solve all those test cases in all the programs. And if they are able to solve it everything, the student, we can assume that he is an industry ready, and he will be able to pass any type of recruitments in the future. In future. Okay, next, project based learning. For each and every courses, if it is possible, you can provide some projects. For example, in our department, what we are following is from four courses like UI/UX design, machine learning, deep learning. For these and all, now we are providing some projects, mini projects. Okay, for instead of giving assignments in a pen and paper method, we are providing some projects, working in groups, or some micro projects is also okay. Okay, so we are providing the students with those projects, and we are reviewing those projects also. And based on that, they are coming with with a beautiful product, with a beautiful project, and encapsulating all the core concepts. For example, for machine learning, the student will be able to um, what able to do a project based on the concepts like supervised learning, or any of the methodologies, unsupervised learning, or from some reinforcement learning. The students will be able to do a project. Okay, there is a project based learning method. Gamification. So gamification by using some games, for example, some role play, you can say some role play, activity based learning, that you can go with an innovative teaching, so that the students will be able to grasp the concepts easily, and they'll be able to learn it properly. Okay, experiential learning, you can make the students to visit some nearby company or nearby industry which is aligned with your curriculum. For example, for environmental study, environmental science and sustainability, if there is a subject, you can make them to visit some nearby sewage disposal treatment unit, sewage treatment unit or something, and you can make them have some experiences, lifetime experiences, how it is being the sewage treatment is being taken, treatment is done, the plan visit, everything you can do it. Okay, so some experiential learning. Next, to from if there is a management people, MBA students, you can make them to visit a particular product-based company, some cool drinks or some beverages company, and you can make them to experience some. How the product is being made and everything. Okay, it's collaborative learning. So collaborative, you can make the students to make a peer a group of students, and you can make a single active learner as a team leader, and you can make that active learner to guide all the other average learners and slow learner students, and make them learn the concepts and everything. That will be more interesting, and also it will be facilitate the students with a more innovative one. Okay, like zigzag method. So zigzag method is similar to a collaborative learning method only. You are making a single student being for example, a problem is given. For example, you can take a subject artificial intelligence. What I'm currently taking that subject, and in that I'm taking a tic-tac-toe problem. Okay, in that problem, the students, when I'm teaching it, they're a little bit understood. Okay, then what I have did is I have made them in groups, and after that I have given a problem, and I have made them to solve that of the tic-tac-toe, and I have made them to construct a search space tree for a tic-tac-toe game, and they'll be able to draw drafted in a beautiful manner. Okay, so they'll be having a better understanding. So you're collaborating a student approach and also your teacher learning approach. So that is a zigzag method. Is one example of a zigzag method. And these are some ICT tools. Why I'm saying is, nowadays in all the curriculum and all the departments and branches, they are inculcating the AI based. Okay, so these are some AI based websites and tools which you can incorporate in your teaching learning methods. For example, if you are providing a quiz, okay, if you're providing a quiz, you can it can you may not make it as a conventional quiz. What we'll be doing in a conventional teaching, we'll be making into groups, and for each group we'll be posing a question, we'll be asking. That is will be a somewhat a rugged one. So but now they are being with the interactive quiz manner. Some you can use some mentimeters. A mentimeter is there, is a website, mentimeter website, quizzes website is there, flow code is there. So these are all beautiful websites where you can have some interactive quizzes. So you no need to go with the Google form itself, conventional Google form, conventional question-based quizzes, everything. You can go some with the interactive sessions. So that the students will be more facilitated with these AI-based tools also. So next is some spoken tutorials. These are also some teaching learning methods, spoken tutorials and virtual labs. So here, when you're coming with spoken tutorials, there are some. It is a website where some eminent persons from IITs, from NITTers, so they and all they have posted some. For example, you're taking C programming. The C programming concepts are well explained in those websites. In a form of a YouTube and in a form of a video, and those you can. Other than you are teaching the same concept in the class, you can make that particular video to be streamed in your class, and in the middle of the videos you can pause the video and you can ask the questions, and you can make it some interactive manner. Okay, so you can visit this website. Next, you can go with virtual labs. Virtual labs is same ACT is providing, and some NITs are providing some virtual labs. For each and every subjects, mostly they are having virtual labs, and you can make them, for example, for circuit designing and everything, for easy based courses and all. So you will be able to design some circuits and everything by using these virtual labs. Okay, yeah, so it will be a very good experience for the students. Next, so this is one of the buzzword in nowadays. In accreditation process, SDG goals. What are all each and every program what you are being conducting, and each and every curriculum what you are framing, what your syllabus is there. For each and everything, each and every bit of process what you are doing, that should be aligned with the SDG goals. That is sustainable development goals. So there are 17 goals available. uh, so this has been framed and has been approved and has to be your curriculum. If you're autonomous, if you're autonomous university or college, your curriculum, each and every curriculum, each and every your courses has to be mapped with at least one SDG, at least one SDG. And for example, zero is a SDG goal. One is no poverty. Two is zero hunger, good health and well-being, quality education, gender equality, clean water and sanitization. You can map with environmental science and sustainability, affordable and clean energy. You can go with some. There are some clean energy related subjects are there. Decent work and economic growth. You can go with financial computing or financial analytics. So those subjects can be mapped with the decent works and industry innovation infrastructure. There you can go with the one credit course or something. Reduced inequalities, sustainable, responsible climate actions, life below water, life on land, this quality education and all maximum you will go with industry aligned subjects. For example, in our Python programming has been aligned with industrial expectations, and it has been the portal based training is being conducted for the students. So there you can go with the quality educations. Okay. So somewhere it has to be mapped. Your curriculum or your subjects has to be mapped with any of these SDG goals, and your program also has to be mapped with some SDG goals, right? And SDG goals with curriculum mapping, I would like to show what is being followed in us. So I think it's not displayed. Okay. I think it's not displayed. I'll just stop the sharing and I'll, okay. I'll share one more thing. Okay, I think it's being shared. Uh, so this is what we have linked. Okay. For example, few examples. So we in our ours is an autonomous college. Our college is an autonomous college, and in our college, we have framed our own syllabus and everything, curriculum and everything. And for example, for our professional communication, what are all the SDGs can be mapped, and based on the SDGs, what are the skill sets the students can be able to acquire, and future skills. What is the future reflection of that particular on studying the particular subject, professional communication? What is the future skills the students can gain? And what are the emerging technologies that can be inculcated with this particular course? For example, for professional communication, no need to go with the same conventional teaching. What could be the emerging technologies that can be inculcated for this? For example, AI powered communication tools you can use, platforms, and everything is there. Okay. Next, NSQF level and the job title. So, on studying this particular course, what could be the job title? What could be the job that can be obtained by the particular student? Public relations officer, team lead, HR manager, everything. So if a matrices and calculus has been studied, so this particular curriculum is based on artificial intelligence and data science department. So if a student, if an AA student is studying matrices and calculus, the STG is mapped as 4 and 9, and what is the skill he'll be getting? Problem solving skills, sorry, for analytical thinking skills, problem solving skills, critical thinking skills. So these are the skills the students will be able to acquire. Next, what is the future skills? Quantity analysis, algorithmic thinking, and everything. Next, after that, what type of tools can be merged with matters and calculus? So you can study this matters and calculus by using data analytics tools and MATLAB, and by using that you can the particular course can be taught. And after that, if a matters and calculus being studied by a student, what is the job title? There is data analysis, quantity analysis, research scientist. So these are certain job roles that a student can acquire. So likewise, there are for all our courses we have mapped the SDGs, right? For example, for computational thinking, if a student is studying, so the SDG goals 4, 8, 9 gets mapped, and after that, what is the future skills, algorithmic thinking and programming automations, and what the job role of a particular student, software developer, system analyst, embedded systems engineer. So these are all few job role a student can be able to acquire. Okay, so these are a few. So we have mapped, for example, in our curriculum, we have at least 45 to 50, 40, at least I think 48 courses. For all the courses, we have mapped all the courses. Okay. Okay.
sir.
I think I have given a outline regarding accreditation process. What are the process being
Hello, sir.
followed by
It's
the
going on, sir.
faculty to make the students to acquire the skill set, particularly the 21st century skills, sorry, students, I think. So I have thought of showing you how to calculate the attainment, COPO attainment and everything. But I think that will take one more session. It will take one more session to calculate everything. So to show you and to explain you the see how to calculate the COs, how to calculate the POs, how the CO and PO has been mapped and everything. It will take one more half an hour. I was just planned for that, but I was not able to, due to lack of time, I was not able to explore to you. Um, so I think I have covered at most all the general aspects for an accreditation process. And with this note, I would like to conclude that a student is sorry, a faculty is not a faculty like our days. A faculty should not be a faculty like what our faculty were. And a student is not, today's generation students are not the students, not like our generation. Okay, so Gen Z students and faculty, they should be updated and they should process all this, they should follow all this process. Then only, apart from teaching, the student should be, and a good teacher will be one who are better engaging the students in a more lively environment. Okay, so for to make the students to be more lively inside the classroom, we have to make them to be more interactive, to be more facilitated with the upcoming technologies, to be more exposed to the societies, and everything is to be taken into account. So a success of a student lies only in the hands of teacher. And we should also update with some AI tools and with some SDG goals and everything. So everything should be inculcated. We should be a multi-talented person. Then only we'll be able to be a good teacher. Okay. Yeah, so only when we are a good teacher, we'll be able to make the student to be a more interactive and lively. And only when all these aspects has been acquired, we'll be able to attain the accreditation. We'll be able to follow a good accreditation. Our college or our university can be able to able to achieve the accreditation. Either it can be a NAC or NBA, they'll be achieved. So the changes should be started or initiated from the minds of a teacher. Only then these every whatever all the above said aspects in this session will be able to be achieved. I think, in my perspective, I'm saying it. I'm sorry if I'm wrong. Okay, with this note, I'll just conclude my sessions. And once again, I thank the organizers for giving me this wonderful opportunity to share my views and everything. Thank you so much. Thank you, participants, for your patient listening. Thank you so much. With this, I'll conclude and I'll just stop my share screen. Okay. Over to organizers.
Thank you, ma'am. Uh, Salve ma'am? Hello? Salve ma'am, is it audible to you?
No, sir.
Ma'am, am I
No, it's
audible to
okay.
you,
Okay,
ma'am?
now.
Okay, ma'am.
Okay, sir. Okay,
Ma'am,
okay,
on
sir.
behalf of the management, principal, HODs, and all the non-teaching and teaching staff of Sridevi Institute of Engineering and Technology, Tumkuru, I would like to thank Dr. Salvi ma'am, Associate Professor and HOD of AIDS Department, Kangayam Institute of Technology, Tamil Nadu, for delivering a brief speech on curricular mapping and accreditation perspectives. Once again, thank you, ma'am, for being with us and addressing one and all in the field of the quantum technologies. Thank you, ma'am. I thank all the
Thank you, sir. Thank
participants.
you so much, sir.
Thank you, ma'am. Thank you, ma'am.
Thank you, sir. With
Thank
this
all the
note, I'll just leave
participants.
the sessions.
Okay, ma'am. Okay.
Okay.
Thank all the participants once again for your active participation. Now, session 1 of the last day has been completed. Now, let us move to the next session. In this regard, I would now like to welcome our expert, Dr. Rakesh L., Director, ATAL FDP Software Private Limited, to address one and all in this session. Sir, please.
Good afternoon, everyone. And just I'm sharing the slides. My slides are visible to you. Hello, Kiran.
Yes, sir. Yes, sir. It is visible, sir.
It's visible today. It's
You can please continue, sir. Yes,
yeah,
sir.
yeah. Let's
Sir,
just a
can you
moment.
go for slide?
Yeah. Just a moment. I'm going.
Okay, sir.
There.
Okay, sir.
Yeah. Just a moment. Yeah. Can you see it much clear?
Yeah, sir. Yeah, sir.
It's clearer to you?
Yes, sir. Clear, sir.
Yes. Yeah, I'm Dr. Rakesh, Director of the ATAL FDP Software Private Limited. And my topic is related to the industry collaboration and future research perspective. From global perspective, also the Indian perspective. Let's look into these two things taken into consideration, how it will have an impact on academia, as well as industry, academia, as well as startup convergence. In Indian perspective and also into the global perspective. And good afternoon once again, and thanks for making the organizers a wonderful opportunity. And so far, it's a wonderful session so far, and all the sessions were informative, and most of the sessions I have attended, and it is very up to the very much standards. As a part of today's thing is concerned, exploring the convergence of quantum technologies with smart manufacturing systems and collaborative ecosystem driving unprecedented innovation, industrial transformation. This is the next slide. Can you see, Dr. Kiran? Can you see the next slide?
Sir. Yes, sir. It is visible, sir.
Is it visible? Yes. Then it's fine.
Yes.
Then we will go in a good pace. Yes. The
Okay,
quantum leap in any moment you can interrupt if anything is there, invisibility or any distractions. Yeah.
Okay, sir.
Yeah.
Okay.
Thanks, Kiran. Yeah, the quantum leap in 2025 from theory to industry reality. The first and the foremost thing is the UN organization, because we need, as we are discussing the quantum research in terms of international perspective, also the Indian perspective. A few minutes from now, the UN organization, one of the globally recognized organization, and it focuses on it focuses on it has decided 2025 declared as the International Year of Quantum Science and Technology by United Nations, making the centennial of quantum mechanics and recognizing its transformative potential for global industries and scientific advancement. Let's little bit brief about the UN organization, where I work for International Telecommunication Union, which is an ITU and which is also an UN organization, and its sister organization, World Health Organization. We have AI for healthcare, and it's also an UN organization. Here, the standards international. They frame policies, they form procedures, and they frame the roadmap for any of the technology. Earlier, I used to attend the focus groups and also deliver my speech at Switzerland. And there is a UN agency, is one of the UN agency subsidiaries at Switzerland, and also the main UN agency is located at New York City, as we know well. And it's a very good organizations where they frame the future perspectives, future procedures, future policies, so that there is a global growth should be the main motive of them, and it also reach the communities. That's the main perspective of UN organizations. And market, second one is the market explosion. Quantum computing revenue projected to soar from billions of dollars in 2024 to again 4 billion to 70 to 100 billions dollars by 2035, with a total quantum technology marketing hitting around 198 billion by 2040, according to McKinsey Comprehensive Market Analysis. And coming on to the industry readiness, the strategic shift from merely increasing qubits counts to stabilizing qubit performance signal quantum computing readiness for mission critical industry application and real world problem solving. This should be the main agenda apart from all other things. The mission critical systems, the time critical systems, particularly in aerospace, as well as some of the real time industrial application, their industrial readiness, a long way to go for industrial readiness. The pivotal moment represents more than technological advancement. It marks the transition from experimental quantum system to practical industrial tools that will reshape manufacturing, optimization, computational paradigms across the globe. Definitely, it will reshape it has to reshape the manufacturing manufacturing sectors, and also there is a migration, some of the platform migration. When you have a earlier system that's a legacy system to the new system, there's the challenges are there. And let's look into the industry 4.0 and quantum computing, where it is. Let's look at that synergic capabilities. Quantum computing's extraordinary ability to optimize complex manufacturing process, supply chains, material design aligns perfectly with the industry 4.0 vision of intelligent, autonomous, smart factories. The quantum advantage lies in the processing vast data sets simultaneously, solving optimization problems that would take classical computers years to complete. As we all know, we have discussed this. It takes classical computers to take long time to certain of the processes and processes, but simultaneously processing multiple variables in manufacturing workflows, real-time supply chain management across global networks, atomic level material property simulation and design, predictive maintenance with enhanced quantum algorithms. There was a case. Why I just highlighted these things is the case study with QO Labs, groundbreaking collaborations, and also collaborations are absolutely necessary. And with collaborations, QO Labs, groundbreaking collaboration with applied materials, demonstrate a company quantum's industrial potential by scaling superconducting qubits to atomic level materials simulations, enabling the development of lightweight electric vehicle alloys and sustainable polymers. That was due to collaboration with a groundbreaking collaboration. Many things are achievable faster. And coming on to the next slide, is it visible, Dr. Kiran? Collaboration. The next slide is it's moving. Slide is moving. Yeah, the collaboration. Okay, Dr. Kiran. Dr. Kiran,
yes,
slide is visible.
Yes, sir.
The collaboration. This slide is visible. The collaboration, the quantum ecosystem backbone. This slide is visible.
Yes, sir.
Yeah. The quantum computing revolution depends fundamentally on strategic partnerships, collaborative innovation across industry, academia, startups, and government institutions. This interconnected ecosystem, an ecosystem is needed. The quantum ecosystem backbone, it should comprise of a strategic partnership. What can be the strategic partnership? Strategic partnerships are collaborative innovations, and also the collaborative innovation should occur across the strategic partnerships, like industry as at the forefront, academia, the startup economy, and government institutions. These are the fundamentally transform they form the backbone of the collaboration. Why collaboration and innovations are absolutely necessary, as we need to move forward with the next technological revolution. We are at the edge or cliff of the next technological revolution, that's the quantum revolution. And in order to make this successful, the interconnected ecosystem approach highlighted by the World Economic Forum enables quantum centric supercomputing to drive and accelerate technological advancement. Let's look at the industry academic partnership, how it is benefiting. One simple example is IBM's collaboration with the Trinity College Dublin and Algorithmic, a company representing a landmark achievement in quantum chaos simulation using IBM's 127 qubit Eagle processor, which is one of the largest digital simulation of the kind to date. IBM has contributed a lot. It also has given a Qisit, which is an open source platform for for us. If possible, if the time persists, I'll again highlight on QSET how we can simulate with the QSET if possible, if time persists. And IBM has given, IBM's contribution is at the forefront in any of the technology right from the beginning of the Industrial Revolution. Similarly, the government-private partnership initiatives, the US Department of Energy, like we have Atomic Energy Division here in India, analogous to that, there is a US Department of Energy, Quantum in Space. Collaboration has expanded, include industry leaders like IonQ, Honeywell, and emerging quantum companies advancing secure communication and quantum sensing technologies in orbital environment. In the last, this one, we had a length of discussion with the sensors and sensor sensitivity, unprecedented precision. These are all were the forefront of our topics a day ago, and advancing secure communications and quantum sensing technologies in orbital environment. Cross-sector innovation hubs. This is another collaborative research centers and quantum foundries are emerging globally to scale quantum hardware manufacturing and develop software ecosystem and bridge the gap between theoretical research and practical application. That's very, very important. We need to bridge the gap between the applied theoretical and applied things. When theoretical research is absolutely necessary, and also at the same time practitioner perspective of practical things are absolutely needed. In these are the things, these are the collaborative mechanism we need to adapt, whether it is across the geographies, whether it is an across the geographies, other way, whether it is across the geographies or across the cross sector innovation apps like industry academic partnerships, government private institutions, that is a public sector public private partnerships, and cross section innovation apps definitely help us to move forward in this quantum journey. These partnership, what does it partnership does? It does leverage complementary strengths, academic research excellence, and also the industry application expertise, startup agility, which is very, very startup economy is always essential because small companies, they do impactful things because they have the urge of doing that. That's how we cannot neglect any startup economy in this. We need to boost the startup economy agility so that there is a there is a vast change is possible, and government resources creating a synergic environment where quantum breakthroughs can rapidly transform from laboratory discoveries to the commercial solution. That's very important. I repeat, in order this partnership leverage complementary strength in academia, industry, as well as startup economy, and also there is a there should be a rapid transition from laboratory discoveries to commercial solutions. Coming on to the next slide, let's look into little bit of players, industry players, little bit deeper into industry players who are driving the quantum innovation. Again, taking the IBM at the forefront and their leadership, IBM's Quantum Eagle processor, which is widely accepted and very famous one, 127 qubits, and powers their comprehensive quantum ecosystem. Their open source QSIT, as I already mentioned a minute ago, QSKIT, a platform which is very open source and which is very, very, you can simulate through QSAM. One of the we have simulated, as I told, that when we are dealing with weather system, smart weather system, quantum weather system, we use the QSET and also the QSAM simulator, which demonstrated high capabilities of the fundamental principal properties of the quantum computing, like superposition as well as entanglement. We can realize through QML, quantum machine learning, because this is the language where we can communicate with the quantum computers, and we can develop some of the useful use cases. Okay, and their open QSKIT and cloud quantum services enable global research collaboration with over 200 academic institutions and numerous Fortune 500 companies accessing quantum computing capabilities through IBM Quantum Network. And this is one of the very, very much interesting quantum leadership in IBM quantum leadership, which caters the needs of the academic institutions, also in quantum platforms, and also some of the small companies. It also caters to the needs of the small compounded companies, even big companies as well, so that IBM has a greater leadership in quantum and its dissemination of the technological aspects. And Microsoft is no exception. Topological breakthrough, Majorana 1 chips represents a revolutionary approach with topological qubits designed to achieve millions qubit scale and fault tolerances. This breakthrough technology promises to overcome the quantum computing limitations and enable quantum AI applications at unprecedented scales. As we know that there are some of the, as a part of implementation, there are some of the hurdles are there, that is the error correcting mechanisms, and also in the chips, they have come, Microsoft has a topological breakthrough, and they have some of the initiation to overcome these limitations. SpinQ, it is democratization across. Democratization means everywhere and everyone. SpinQ pioneer industry grade superconducting computing computers alongside the portable NMR quantum devices, democratizing quantum education and experimentation, which is very, very important. Their approaches to make quantum technology accessible to educational institutions and smaller research organizations worldwide is an exceptional. That is, they want to have a democratization of access to educational institutions, and in order to have experimentations. These industry leaders demonstrated diverse approaches to quantum computing development, from a cloud-based accessibility, IBM giving it a cloud-based accessibility and a topological innovation, to educational democratization, and other other company like SpinQ democratization, collectively advancing the entire quantum ecosystem and accelerating commercial adoption across the industries. That's what we need to have, a collaborative approach, and a collaborative approach, systematic approach, strategic approach, in order to drive this quantum innovation forward. Coming on to the next slide, the quantum AI, which is very popular one, the next frontier in the industry 4.0, and the convergence of quantum computing with artificial intelligence represent the most significant technological advancement in industry 4.0 transformation. 4.0 transformation. Quantum AI accelerates machine learning algorithms, optimization processes, and complex system simulation beyond the capabilities of the classical computing systems. The quantum advantage realized. Google's revolutionary Willow chip, which is always in news, completed computational benchmarks in minutes that would require classical supercomputers trillions of years. That's the capability of the Google revolutionary Willow chip, which is a capability of minute-wide operations, demonstrating the unprecedented quantum advantage in practical applications. Accessible quantum AI startups like Saxon Q are developing portable quantum computers that democratize quantum AI application, making advanced computational capabilities accessible across diverse industries and research institutions. And industrial integration, manufacturing systems enhanced with the quantum AI enable real-time optimization, predictive maintenance, and autonomous decision making that surpass traditional AI capabilities in complex industrial environment. What I mean to say is, quantum AI has the capabilities to make things much more precise, much more better, much more impressive. Quantum computing combined with AI is not just an incremental improvement, it's a paradigm shift that will redefine how we approach machine learning, optimization, and complex system simulation across the industry sectors. This is one small example where the convergence of two technologies, convergence of quantum technology with advancement in AI will have a drastic impact. And coming on to the industry, let us look into some of the further industry models. We have discussed about IBM capabilities in leadership in quantum computing. We also just discussed about the Microsoft's leadership capabilities, and also we have discussed some of the companies, some of the other companies. But let's look into the industry collaboration model case studies. Strategic partnership and investment models are reshaping the quantum computing landscape with a diverse collaboration approaches, driving innovation and accelerating commercial development across global market. For example, SoftBank, which is very, very famous in many of the, recently they were with the robotics. They built certain, they are into the many areas, but one specialized area which I have come across, which is very impressive, is the robotics areas of bank. And they have a robots in almost all the sectors, particularly also in the educational sector, in the entertainment sector, also in many of the sectors they have their robots, and their robots are very, very efficient efficient, and Quantinuum, in order to a company, and SoftBank and Quantinuum both accelerate quantum technology development as well as deployment processes. Armco and Pascal represent major corporate investment in quantum startups, providing capital, market access, and industrial expertise. That's very important as a part of, in order to boost the startup economy. The bigger players, they come forward in investments and providing capital, market access, also the technology sharing. That becomes very important, so that it's not only the big players, it is not only the big players, it also give access to the smaller players, smaller companies, smaller players, so that the quantum innovation continues to grow. Yeah, allow innovation hub development. This is another advantage. Strategic corporate partnerships are necessary. Innovation hubs are necessary. Collaborative quantum foundries and research centers emerging worldwide to scale hardware manufacturing, develop integrated software ecosystems, and bridge academic research with commercial application. That's what very important. Academia forms the basis for anything. They have to integrate any of the industry you take per se. They have one or the other way academic collaboration, because most of the things comes from the laboratory to the that's what commercials. That's what in the last slide I mentioned, from laboratory to commercial aspects, laboratory to market. That's very much essential. And there are worldwide hardware manufacturing and software ecosystems. They always try to bridge with academic research with commercial applications. That's very essential, and it's also a very positive move to the academic research, where you can realize the quantum applications. And international government initiatives, I already told that. UN organization, one of the international agencies which provide the platform for any of the new technologies. They make procedures, policies. They are very, very particularly International Telecommunication Union, ITU, and along with the sister organization, there is a UNESCO, which also promotes education. And these organizations, they have a policies, and UNESCO has a best policy, what we call as a ethical AI, or ethics of AI. They were the first to start with ethical AI practices, and then all the industry partners communicated. One of the recently in the last December, where I was in Infosys, where there's an ethical AI. Ethical AI means like fairness, biases. They were discussing about length of discussion related to bias. This UNESCO, an international organization, was the first at the beginning, where they started ethical aspects of the artificial intelligence. Similarly, again in the quantum also, there are so many ethical aspects when come into picture. There may be, in my opinion, there will be ethical aspects should also be considered, where you think of fairness, biases in technology, fairness, and many other ethical aspects are there we need to think of. And now one such international government initiative I come across here is Japan's AIS collaborations with QERA and INQ. INQ is very famous, plus Qatar investment. That's what you see, the trilateral collaboration, trilateral industry collaboration. We have seen the trilateral, bilateral trade with countries, bilateral, trilateral trade with countries, but now you can see that bilateral as well as trilateral with investment corporations, with the companies, so that aim is to move quantum innovation and quantum technology forward. Japan's AIS collaboration with QERA and INQ plus Qatar Investment Authority's partnership with Alice and Bob demonstrate global government commitment to quantum technology advancement through strategic public-private partnerships. This is one of one classical example of international government initiatives. We have seen some of the use cases, like say two corporates, and also a few of the corporates, big corporates coming on, narrow down into the smaller corporates, and also the startups, and also the intergovernmental organization making policies for procedures and policies for the global approach, and also the bilateral as well as the trilateral, what we call in terms of countries, in terms of companies, and they are combining to have this quantum movement forward. Investment landscape analysis, the quantum investment ecosystem demonstrates the remarkable growth, and this is working already. This what I talk about, this bilateral as well as trilateral coalitions with the companies. This is already working. The quantum investment ecosystem demonstrated remarkable growth and confidence, with 2 billion invested globally in 2024. Government investment share increased to 34%, reflecting strategic national importance and long-term commitment to quantum technology leadership. That's what we'll see our national importance commitment, long-term commitment in the future slides when we go into India's quantum approach in a few minutes from now. Let's look at the balanced public-private funding approach, ensure sustainable development while mitigating commercial risk and maintaining strategic national interest in quantum technology advancement. Over and all, put it all together in an umbrella. These industry collaboration models and case studies will end up with a strategic partnership investment models that reshape the quantum computing landscape with a diverse collaboration approach and our aim is to drive innovation and accelerating commercial development across the global markets. Then coming on to the challenges and research directions, and definitely the challenges are there, hurdles are there, and we need to come up with that, because any new system does not comes with a cooked one. It has to be, we need to have a lot of hurdles, or technical hurdles, workforce in research priorities. All these hurdles are there. Then we have to have a strategy. We need to have a mechanism. The first and the foremost technical hurdle is, as I said, that error correction and qubit fidelity remain the most crucial challenges, because crucial challenges limiting quantum computing practical application. Yeah, theoretical aspects we can talk a length, and we can be impressive with the technology, we can embrace the technology, but when it comes to the execution capabilities, when it comes to the practicality, these error correction mechanisms and fidelity of the qubits remain the most critical challenge limiting quantum computing practical applications. Current quantum systems suffer from decoherence. I was speaking about coherence and decoherence mechanisms, which was a part of coherence and decoherence mechanism, which was a part of interference. It was one of the fundamental quantum phenomena, which is called as interference, where at the interference, we were at the interference, and we have a famous double slit experiment, and also we talked about the maintaining the quantum states. That's what the decoherence here. Current quantum system suffered from decoherence mechanism. That's what, in order quantum sensors relay maintaining coherent quantum state to extended periods. Coherence time determines the sensor's sensitivity. Longer coherence enables better precision through extended interrogation periods. That's the coherence and decoherence mechanisms. And in that longer period or extended period of maintaining coherent quantum state is a challenging, and we need to come up with those type of challenges. This is not the one challenge, and there are gate errors and measurement inaccuracies that prevent reliable large scale quantum computations. For example, Microsoft logical qubits and Chalmers University groundbreaking research into magnetic quantum materials represent promising advances towards solving these fundamental technical challenges, achieving fault tolerant quantum computing. At the end of the day, we need to have a fault tolerant quantum computing, and one of the things we mentioned is like coherence and decoherence mechanisms. It need to be appreciably, it need to be taken care. That's the extended period of quantum states for an extended period, and some of the decoherence mechanisms, which includes like environmental noise, temperature fluctuations, magnetic fields variations, vibrations, advanced isolation techniques, cryogenic operations, and active stabilization systems are employed to preserve the quantum coherence. That's what, these are the things in order, apart from maintaining coming up technical hurdles, we need to come up with mechanisms in order to handle the technical hurdles. With the workforce and ecosystem maturity, the quantum computing industry faces a significant talent shortages and varying levels of ecosystem maturity across different regions and sectors. Deolite's strategic scenario highlights substantial risk if early action isn't taken to address workforce development and operational gaps. Deolite, as we know, that one of the premier industry leaders, and the quantum workforce is the biggest challenge everywhere. When we are able to embrace the new technology, we need to have a strategic workforce. We need to training, and also in order to make the equip them, that is quite challenging, and we need to workforce ecosystem and maturity level. It doesn't mean that we need to just employ or recruit to the workforce and keep it. It's not like that. It should be again and again, over again. In order to check that, in order to see that this workforce are ready for take the next level of challenges. And DLIT has come up with one strategy scenario highlighting educational initiatives, professional training programs, and cross-industry knowledge transfers are essential to building the skilled workforce required for quantum technology adoption and maintenance and implementation. That's the DLIT initiatives, educational initiatives from DLIT. Same thing when AI was adopted, NVIDIA came across. NVIDIA came across for educational institutions with their GPU access with a very what you call affordable prices, so that NVIDIA's GPUs across the country, so that across the country and across the globe, so that everybody have an access to those resources. Resources are very important, and educational institutions need to be maintained, motivated, and the professional training from the industry is needed, so that there will be steady progress can be achievable. And also the future research priorities, which include critical research direction, include scalable quantum hardware architecture. That's what quantum hardware architecture, quantum safe cryptography protocols, quantum sensing integration with classical systems, and hybrid quantum classical systems, classical computing models that leverage both paradigm strength. That's what here critical research directions include scalable quantum hardware architecture, and also the protocols, quantum sensing protocols, quantum sensing integrations. They are very essential, because we need to in order to have these priorities research, then interdisciplinary collaboration is necessary, because the quantum computing is an interdisciplinary research. There should be a physicist, there should be a computer scientist, there should be material engineers and industry practitioners is essential for addressing these complex changes and accelerating the accelerating the practical quantum application. That's what it's an interdisciplinary approach and collaboration between the different different brains. Then only this will become success. Because if you say that a cryptography architecture, similarly take an example of one sensing protocol architecture, there is a state preparation, there is a state evolution, and there is a readout. The architecture of quantum sensing protocol is like three-part play. First, you need a state preparation where you get quantum system ready. Then comes the quantum evolution state, where system interacts with whatever you are trying to sense. Finally, there's a readout where you measure the system to get your result. This is simple. I gave you a simple example of a protocol structure in sensing sensing protocol architecture. In order to have this implementation of these protocols, you need to understand from the physics aspect. Then you need to come into the electronic aspect. Then you need to come across the computer scientists, like say implementation aspects, and you may need material engineers as well. And that's why this is an industry approach, and this need to be trained. This need to be disseminated to the academic institutions, or whether it is a startup, whether it is an academic institutions. Then only these things, in order to make successful journey and in order to overcome the challenges, we need to go in this direction. That's a collaborative approach, and collaborative approach is this will help much better things. Okay. And coming on to the road ahead, the quantum computing role in industry 4.0 transformation. The convergence of quantum computing with industry 4.0 principles will fundamentally transform how industries operate, innovate, and compete in global marketplace. The embracing the quantum collaboration for a smarter future. The quantum future is now quantum computing's transformative promises within immediate reach, but realizing the potential requires strategic partnership across industry, academia, and government institutions. The convergence of quantum technologies with industry 4.0 will accelerate the vision of intelligent, connected manufacturing and create unprecedented opportunities for innovation and growth. Strategic investment imperative investment in strategic investment imperative. Organizations must invest in quantum capabilities, talent development, and collaborative partnership to remain competitive in rapidly evolving technological landscape. Collaborative innovation model, strategic investment, collaboration innovation model, and leadership through action. The time for quantum transformation is now. Leaders who act decisively will shape the future of the industry and research in the quantum age. The quantum revolution is not a distant probability, it's today's reality and requiring immediate strategic action, collaborative innovation, and visionary leadership as essential. And we are seeing that some of the industries have already shown the leadership, particularly IBM, the Microsoft IonQ, and many a name. The name is endless. The name is endless, and they have already shown they have already embraced the collaboration for the smarter future, and this transformative promise is within immediate reach, but the potential strategic partnership across academia and industry and government institutions should go on for a longer period of time, so that they have a longer vision, and that will make the connected manufacturing and manufacturing and industry 4.0 applications become accessible to everybody. The startup agility, industry expertise, academic research, they should go hand in hand. Then only the robust ecosystems can be possible. Robust ecosystems can be possible with with these type of things. And then coming on to the, let's look into the next. Let us look into the next one is the industry 4.0 alignment. Let's look at collaboration and future research from the Indian perspective. Let's look at this from the Indian perspective, exploring the India strategic integration of quantum technologies with India 4.0 to revolutionize manufacture, enhancing cybersecurity, and driving sustainable industrial transformation. Our particularly from this industry in Indian scenarios, in everywhere global, the cybersecurity has become the security challenge has become the major aspect, and we believe that with the quantum technologies there should be some mechanisms, because nowadays cybersecurity, as in almost the most of the system, we are insecure of the security mechanisms, particularly with the cybersecurity aspects, because every day, whether it is any of the mechanisms, authentic and authorization, we feel that insecure, and we hope that with the integration of the quantum technologies there should be some mechanisms, so that cybersecurity, there should be a strong security mechanism, and also there is, as we see that there is a revolution in the industry revolution will be definitely, there will be a industry revolution for sustainable industry transformations. Let's look into the collaboration, India's industry collaboration and future research from Indian perspective. Yeah, the India's quantum leap, the national quantum mission. Till now, we had a discussion of. Till now, I took you to the deep dive into the global perspective of some of the major players, and how the international governing bodies, international mechanism will make quantum computing. In order to make quantum computing, what all their perspective of collaboration, their perspective of bridging the gap between academia and industry, their perspective of promoting the startups, their perspective of making access to the hardware, access to the hardware, access to the resources, I have discussed, and also given you some of the case studies where they are successful with some of the industry partners. And now looking into the quantum leap, it's a very big number. $750 million investment from 2023 to 31 to India is no exception. We are moving towards the largest economies, one of the fourth largest economy, and we have everything in India. just to tell you frankly, before 2024 and before that, before mid and aftermath of 2024, every time I used to go to other countries in order to have learnings for new technology, whether it is a workshop, whether it is a conference, whether I need to deliver my speech, or whether on behalf of my company. But the 2020, there is a drastic changes I see from 2024 mid and up till now. now there is a drastic changes. We used to go to the other countries, and people are from the other countries are coming to India. Wherever you see, whether it is a ITU yearly event in New Delhi, or else any other things in Bangalore or any of the major cities, we see that many of the other countries, many of the foreigners, they come to India because they see that there is India is a growing economy, and there is a technology is available here. When we talk about technology, it is the manufacturing sector. The manufacturing sectors are at a rapid pace. It is not only anything like information technology or any space. It is equally in all other space. We definitely see in the future there will be a in manufacturing sectors as well as there will be a transformation, and that's what I feel. And there is a lot of scope, everything is in India now. That's another advantage, because because of the national point, because of the initiation from the governments at the state as well as central level both. We will see in these slides the national quantum mission NQM, which has so much of plan investments up to end of 2030 to position India as a global quantum leader in rapidly evolving quantum landscape. Quantum computing from 50 to 1000 qubit intermediate scale systems, secure in order to have a secure communication. The definitely satellite based quantum network, satellite communication will have a edge. And who knows, today we are talking about quantum, tomorrow who knows, there may be a day we may go into the different interplanetary places in the future, down the line 20 years or 30 years, or down the line 20 years plus, we may go to the different planets, and we can have a day as on the as we are or on the earth. There may be chances as well. Quantum sensing, ultra precise measurement technologies, there was a length of discussion with respect to the sensing. Sensing plays a critical role. Sensors plays a critical role. That's what whenever you talk about quantum computing, one is the quantum computing, that the handling of the qubits. Then second one is the communication, that is a protocol, and a secure mechanism through protocols, and different applications of the secure communication, satellite-based communication at the highest, and quantum sensing. Quantum sensing plays a critical role, and quantum sensing definitely has we have seen the working principles in earlier speeches, like precision and sensitivity forms the basis for quantum sensing, and quantum sensing is very much important. The quantum sensors use the wonderful properties of quantum world to make measurements, and as we in different earlier speeches, we saw that there were atomic clocks, there were squids, superconducting quantum interface devices. They all form they sensitive. We have seen that how sensitivity and precision, was very important. Taken an example of an atomic clock, super precise. You can think of a super precise pendulum. Instead of swinging back and forth, it uses the vibration of the atoms, which is incredibly constant. That's what, when you talk about quantum sensing, the applications that forms a part of quantum sensors, optical lattice clocks. Also, we have seen there was an international quantum clock, which is very precise and which can be used for many applications, like what some of the applications which includes some of the applications which includes navigation systems. Apart from that, the precise timings, and also what we call it as we have a steady, what you call it, the internet mechanisms. The quantum sensor exploit the fundamental quantum sensing, and quantum sensors exploit the fundamental quantum properties, superposition, entanglement, and quantum interference to suppress the classical measurement limitation. That's why we need to have quantum sensing. Why we have to give the priority for quantum sensing, because this is sensors as a starting point, and quantum sensors are no exceptions. And the core quantum sensing technologies, when you talk about quantum sensing, the core quantum sensing technologies are atomic interferometry, nitrogen vacancy sensors, trapped ion systems, and they are confined to the electric fields, electromagnetic fields, that acts as a highly stable quantum sensors for electric fields. And nitrogen vacancy sensors, diamond, in order to have minor cracks in a diamond, there is a nitrogen vacancy sensors, and these through quantum sensing techniques, this become very precise, and atomic interferometry that utilizes matter wave interference of unclosed atoms to measure acceleration, rotation, and gravitational fields. And that's why the NVC basically identify there are some sensors, quantum sensing mechanisms using quantum sensor. NVC basically identify the tiny defects in the diamond structure. Then the four thematic hubs across the premier institutions driving research in computing is communication, sensing, meteorology, and material development. These are all we have seen in our earlier talks. All this we have come across the four thematic hubs of across the premier institutions driving the research in quantum computing, or computing, communication, sensing, metallurgy, and material development. These are already in the process in the premier institutes. That's what sensing becomes a critical part, and also the research in computing, communication, sensing, metallurgy, and material development. These are already in the pace in the premier as a part of national quantum mission. Then industry 4.0 meets the quantum transforming, that is manufacturing, supply chain optimization, quantum algorithms, solving complex logistics puzzles in real time, reducing cost, reducing cost, and improving efficiency across global supply networks. And security, as I said, that security plays a critical role, and quantum security is no exception. Quantum key distribution, and earlier we have all the type of cryptographic methodology were discussed. Here a quantum key distribution is there, QKD, protection industry 4.0 infrastructure against sophisticated cyber threats and ensuring data integrity. That's what I was telling about the cyber security in the beginning of the in the beginning of the slide. I told you that a few slides away, I told security aspects is very important, particularly the cyber threats. Cyber threats can change, cyber threats can weaken the geographies, it can weaken the countries, it can weaken anything else, individuals. It can weaken the individuals because cyber threats because cyber criminal penetration is such a large, and we need to, and also I said that data integrity can make us more secure, and this is with the quantum computing and quantum key distribution capabilities. This can be possible, and that's one of the greatest advantage for us. And manufacture, that will be the greatest advantages for us. And manufacturing excellence, BMW and Pascal collaboration, that's again collaboration, demonstrate quantum algorithms enhancing metal forming and aerodynamics for automotive innovation. Yes, the ultimate goal of the collaboration is the ultimate end of the day, there is an ultimate innovation, and innovation should be possible with collaborative approaches. This becomes very faster. And BMW and Pascal collaboration demonstrate quantum algorithms enhancing metal forming and aerodynamics for automotive innovation. And this is how industry 4.0 industry 4.0 will be benefited by the collaborative approach. Innovative approach is possible. It will collaborations and collaboration and also the co-creation within the supply chain management, within the security aspects, also in the manufacturing excellence. This will become definitely it will be a merit for the quantum computing mission. And let's look into the strategic industry collaboration powering India's quantum ecosystem. Recently, we have seen in the papers, Quantum Valley Tech Park, that is IBM, TCS, and Andhra Pradesh government partnership. I mentioned that the partnership across the geographies, between the geographies, and also the public-private partnership across the governments will definitely benefit the quantum movement. The Quantum Valley Tech Park, which has been announced by the government of Andhra Pradesh, IBM, TCS, and Andhra Pradesh government partnership, launching India's first quantum tech park with 156 qubit IBM quantum system by 2026. This is one of the greatest move. And enterprise applications, TCS driving quantum use cases across healthcare diagnostics, financial risk modeling, and logistic optimization, and smart manufacturing systems processes for enterprise application. TCS is driving quantum use cases in these particular domains. And startup innovation, Bangalore's KPI AI scaling quantum computers from 25 to 1000 qubits by 2028 with National Quantum Mission support and funding. What I mean to tell is a startup supported by the National Quantum Mission, Startup India, and also the Software Technological Park. These will definitely boost the startup economy, and even there are better startups there. One QPI AI, Bangalore is one of the finest startups which is scaling in quantum computers, and Bangalore is also no exception. The government has also announced just last week 7 to 10 days or 7 days ago, a tech city, a park, 1,000 crore rupees from the government of Karnataka, where they're going to, where they will have a quantum park, quantum tech city, quantum city in and around Bangalore. That is also initiation. That's what there should be initiation from the across the geographies, between the geographies, and also between the governments. Then only there will be a fastest embracement of the technology like this. One of the best initiatives, the Quantum Valley Tech Park at the from IBM and TCS and the Andhra Pradesh government, which is a very good move. And also the startup innovation supported startup innovation, which has been supported by the quantum mission support to the QPAI scaling in order to scale the quantum computers from for thousands of qubits. The next one is the building a quantum talent and innovation pipeline academic partnership, TCS with IIT Tirupati and Infosys Quantum Living Lab at academic partnerships. It's another one of the good initiatives, and global collaborations. It's, as I said, that collaborations across global collaborations. In the initial talk, I told about the global partnerships. That's Wipro and Tel Aviv University partnership. Tel Aviv University, one of the recognized one, because as we know that Israel forefront in technology, and a company, a forefront technology, Wipro has come up with a Tel Aviv University partnership. Definitely you can, in order to address the global quantum talent shortage, to sustain India's competitive edge in emerging technologies, these companies, they served Indian growth like anything. We should appreciate our companies, Wipro, like TCS. They come up with joint collaborations with premier institutes and also other academic institutions, and global collaboration with the Tel Aviv universities. They address the global quantum movement, and this is how we need to have building a quantum talent and innovation pipeline. That's what, in order to build the quantum talent and in order to make the innovation pipeline, these are all these collaborations across the collaborations globally, across academia, across industry is almost is every time it is essential. And quantum technologies driving the future and driving future research frontiers, the quantum materials, developing superconductors and topological materials for the next generation qubits and ultra sensitive quantum sensors with unprecedented precision. I earlier told that unprecedented precision. Why we need unprecedented precision? What is unprecedented precision and why we need that unprecedented precision? In order to solve unimaginable and intraceable problems, we need unprecedented precision. Quantum sensors have the capability of unprecedented precisions, and these quantum materials will be and topological materials for the next generation qubits this play a critical role. And this precision and sensitivity are very important, and really fundamentally we can think sensitivity, how well our sensors can pick up the tiny changes in what we are measuring. Tiniest of the whisper, we should be able to listen from microphone. That's the sensitivity. And these quantum sensors, they use the wonderful fundamental properties. I need not to repeat it again, because we are towards the end of this session, the end of this FDP, and we are familiar with the fundamental properties of the quantum technology. Advancing sensors, magnetometers with femtosecond sensitivity and atomic clocks enable precision navigation and secure quantum technologies driving the future. These are all the future frontiers. The quantum clocks, magnetometers, atomic clocks, magnetometers, they plays a very critical role, and they are advanced sensing mechanisms, atomic interferometry, and they play a very important role. That's the Tesla sensitivity. When you talk about the Tesla sensitivity, the current NV center magnetometers, that is nitrogen sensor, NV center magnetometers, achieve magnetic field sensitivity approaching the Tesla level. What does it mean to say? That femtosecond sensitivity and atomic clock enable precision and navigation, and they secure communication. Due to the advanced sensing mechanisms, the quantum sensor sensitivity, they follow the fundamental scaling principles. The advanced sensing mechanism is due to the fundamental scaling mechanisms, the fundamental scaling mechanisms from a standard quantum limit, that is classical sensors, class scale sensitivity square root of measurement time or particle number n. That's the normal standard quantum limit. And when you talk about advanced sensing, it is always with the Heisenberg limit and Tesla limit. What does it mean? Heisenberg limit is always the quantum sensors which can achieve inverse scaling with practical number using entangled probe states. That is, it represents the minuscule changes in something in the minuscule changes that uses quantum entanglement. What happens in Heisenberg sensitivity is it uses the quantum entanglement, which is like linking two particles together so that they share the same fate. The entanglement lets us to make more precise measurement than the standard one, so that precise communication is possible, precise navigation is possible, because we are talking about advanced sensors. Advanced sensing capabilities have Tesla sensitivity, and when you talk about Tesla sensitivity, it is 10 to the power of minus 19. That is what we call it as that's the equation. And basically the minimum amount of noise you can expect in the measurement, even with a perfect equipment, that is possible. Okay, that is possible with the advanced sensing mechanism. And again, quantum networks, multi-node quantum networks enable scalable, unhackable communication infrastructure across cities and international borders. That's what the quantum networks should provide. Reliable communication is possible, and this should be the driving feature of the research frontiers. Quantum technology, these are the things quantum technologies frontier research should encompass as advanced sensing capabilities, quantum materials, superior quantum materials, and there should be a secure quantum communications networks. Then what are the challenges and opportunities in Indian quantum journey? The challenges: talent scarcity in quantum physics and engineering. Definitely, when there is a migration for or rush for one technology, one new of the technology, embracement of the technology, definitely there will be shortage. That's the skilled workforce, and the scarcity in quantum physics and engineering, and high infrastructure cost for quantum facilities. But there is an initiation. Premier laboratories are already started working, and also there are high infrastructure cost for quantum facilities. Already National Quantum Mission has already invested, and they're working on the quantum computers. Need for indigenous technology development, our own indigenous, that is also possible, because when India embraced, we wanted to have our own LLMs, and it started due to the India AI mission already started building their own LLMs, and this is possible with the same with the quantum technology. Even though quantum technology, we even have a quantum mission, so that we can parallelly we are also taking this as an advantage, the technology. That's the capability of India. We are embracing anything coming to the India. That's the greatest move, and that's why definitely the day is not near where we are not only reaching the biggest largest economy, we can also be the biggest economy. That type of capability is there, because whatever we saw in the global, I took the global scenario, we are not short from anything. In India also, I don't feel that there is a shortage in anything else. And what are the opportunities? Leveraging India's vibrant startup ecosystem, that's the greatest. And leverage India's vibrant startup ecosystem for innovation. That's one of the greatest strength. And the government funding and policy support acceleration, that sits there, that we are seeing since from the India AI mission, semiconductor mission, and also now the quantum mission. We are seeing that there is no shortage. There is a free flow of funds, and the policies which are always they are always in support for us, and that's what. And also there is a lot of support from the governments. Global collaboration for technological transfer, this is possible. And there is a plan holiday, like a plan holiday. There is a tax holiday has been mentioned for small companies, MSMEs, and the companies which are at a different scale. Some of the small companies which embrace the new technology, a government has always given a plan holiday, tax plan holiday for taxes, and the global, and also they have a mechanism for global collaboration for technology transfer. It is very, very easy. You have a company in India and you can have a company in Finland as well. One of the smallest country, but still richest in technology and richest in technology. If I want to collaborate, you have a very good technology in it. I want to collaborate similarly with India. I want to collaborate with Israel, and Israel like this through startup economy or startup India, or you have through Indian Indian company mechanisms. It is easily integratable, and technology transfer is also possible. But when you talk about the technology transfer, many things comes into picture, which should have international standards. There are standard policies, procedures, and also in the products there are so many what you call compliance mechanisms. If you are able to follow, those are all the paper mechanisms. If you are adapted or if you follow it, and global technology transfer is always possible, even though it is not that that easy. But the what you call the directions, what it has been formulated, make things will be simpler. And ethical and regulatory framework essential for responsible quantum technology deployment and governance. I spoken about ethical. I told you in the beginning ethical AI, because when things were at going forefront of the when we are embracing the artificial intelligence, and there was a question that ethical aspects consider gender gender biases in AI, and there were so many biases you need to consider. Similarly, the biases when we embrace the quantum technology, we should have a regulatory frameworks, regulatory compliances, and also the ethical framework. Ethical framework is very essential. We should spend minimum, or we should have ample amount of time for ethical aspects of technology, and which is nothing like ethical aspects of technology, more principal rules and values that guide human conduct, helping distinguish the right from the wrong, and foster cooperation, justice, and freedom. These are all the ethical principles when we embrace ethical principles. When we think of ethical and regulatory framework, we should consider there should also be ethical frameworks also be formulated for quantum technology and deployment and governance. So these are all the challenges and also the opportunities in Indian quantum journey, which are having in putting it in an umbrella. It has an ample opportunity for Indian quantum journey. And with that hope, definitely we can proceed with we can embrace new technology. Quantum as a catalyst for sustainable industry. Sustainable development is very much essential. We already came across circular economy, resources optimization, and waste reduction through quantum algorithms. The circular economy will be definitely benefited through resource optimization and waste reduction through quantum algorithms, and also the energy efficiency, circular economy. Because we know that conservation, we know that energy, how much energy management and sustainable material innovation. Through sustainable material innovation, energy management is possible, and energy efficiency can be enhanced, can be enriched. And also the digital security, beginning from the beginning, I told that security is very important, particularly cyber security, which is a digital securing ecosystems, critical for the industry 4.0 resilience. In order to have resilience and scalability, digital security is very essential, and quantum can act as a catalyst for sustainable industry 4.0. Quantum computing enables circular economy principles while enhancing manufacturing sustainability and securing digital infrastructure for long-term industrial growth. In order to have a long-term industrial growth, circular economy principles should be given priority. Circular economy, which has the capabilities for resource utilization, resource optimization, and waste reduction, which are the capability in the circular economy. We need to promote circular economy, and also we need to concentrate on energy efficiency, and we need to prioritize digital security. This quantum can be a catalyst for sustainable development of the industry, sustainable industry development. So India's vision from quantum research to quantum enabled economy. That's what quantum vision from quantum research to quantum enabled economy. Leadership goal. Like see one popular example I gave you initially, IBM leadership. It doesn't mean that the leadership, it should able to come and in the forefront. They should give technology. They should platform. IBM has given the platform which is helpful for the development of, which is helpful for open source platform like that. Leadership goal: leading quantum communication, sensing and real world applications across the sectors. Economic impact: creating high-end jobs, attracting global investment, fostering vibrant quantum startup economy. All this we have discussed. And also the national integration, aligning with the digital India, make in India, skill India, and sustainable development goals, in order to make these quantum applications, quantum use cases, societal needs, which should meet the societal needs. We have definite goals. Each and every sustainable goal has its own. It has an impact to the one or the other way. It is impacting the economy and also the society. The sustainable goals. Our goal, our aim in the quantum research to quantum enabled economy should have an economic impact that should create more and more jobs in this sector, and it should attract investment from across the globe, and it should have a vibrant quantum startup ecosystem, which is essential as a part of digital India, make in India, skill India, sustainable skill India. They need to be promoted in lines with this. Then definitely the Indian vision for quantum research to quantum enabled economy is possible. Quantum enabled economy is possible. And just a moment. And coming on to the quantum future is the quantum future into actions, bringing into actions, which need to embrace collaboration. A few things we need to put under the umbrella. We need to embrace collaboration. Why we need collaboration? We discussed in a depth. Global collaboration and also the collaboration across the geographies, across the states. We saw it, how these collaborations might help, and also we saw that investment is any primary part. Investment in talent. We see that skilled workforce is needed for any of the things we have discussed in our early slides. Infrastructure is needed, and innovation to secure the India's position in the global quantum race. To build the future together, create a quantum powered industry 4.0, which is driving economic growth, security, and sustainability. That's build. In order to build that, this is the quantum's destiny awaiting, and we are already forefront in this. We are already started this. We have embraced the collaboration. We have a strategic investment as well from the at the national level, also the state level, and we have an ambitious to build the future. These are the capabilities are there, and that's how this quantum. This is my topic related to particularly related to the future prospectus research, as well as collaborations. How collaborations in across industries, across communication should be there. That's how it is. That's how this one is there. If you want to have a little bit more about some of the technical aspects, I'll just share you the others. Yeah, Kiran is hello. Kiran. Hello, Kiran. Hello,
Yes,
Dr.
sir. Please tell me,
Yeah,
sir.
yeah. Are you able to see the screen?
Yes, sir.
Yeah, we have another. How much time is left out? Another few minutes are there, so that we
Yes,
can
sir. 10 to 15 minutes.
yeah. Then we can go with little bit into the technological aspects, because QML forms the basics of future. It will help industry collaboration and future research. This quantum computing and QML also forms the basis for that. Let's look into the QML aspects. with some one or two, if you have any case studies or anything, and also we can also open for questions also from the audience. Exploring the convergence of quantum technologies and machine learning through strategic partnership, because this how means in order to have groundbreaking research activities, then computational, we look into the computational advantages as well. The quantum from the look into the quantum revolution current state of affairs, that we have seen that the quantum computing has transitioned from the theoretical physics to the practical engineering, with major corporation investments, billions in quantum research and development. The field now stands at the critical juncture where academic research meets the industrial application, because the field is now at the critical point of juncture where academic research meets the industrial application. The current quantum system demonstrates quantum supremacy in specific tasks, whilst quantum machine learning algorithm showing promising results in the optimization problem, pattern recognition, data analysis, and classical computer struggle to solve efficiency. Leading technology companies have established quantum computing divisions, creating ecosystem drive for collaboration between academia and industry. Most of the companies, they have their quantum computing divisions, and they always bridge. Yeah, as we discussed, they try to bridge the academic collaborations, so that some of the research, some of the activity research, converting the lab activity into the commercial stage. The tech joints, these are the players driving collaboration. That is already we IBM's contribution to the quiz kit we already discussed. That is the open source platform, which is very impressive. IBM quiz kit, it become necessary to understand, is a really powerful tool from IBM that lets you work with quantum computers. It's like a set of building blocks that you can use to create and run quantum programs. Now that QuickSet, you can import libraries you need and you can have a Python scripts as you can write your scripts. You will need to import the libraries, and you can create with quantum IBM QuickSet. You can also create a QSAM environment, QSAM environment, and that can be, you can run the simulation aspects through QSAM. That's another part. And also the Microsoft also has given some of the platforms where, and another one of the pennyline.ai, there is another one company which provides a platform to run the scripts. And the scripts, you can have your logics, and you can have established a quantum, and Microsoft and Amazon as a quantum cloud platform that research partnerships with universities worldwide, providing access to quantum hardware and development tools. These are some of the facilities provided by driving collaboration, key industry players providing driving collaborations. Quantum startups, some of the companies like Rigetti, IonQ, we discussed IonQ earlier. IonQ in collaboration with one of the company plays a critical role. How they have come up, we have a case study. We have a case study with IonQ, one small case study in earlier slides. And Zandu, a pioneering novel quantum architectures and creating specialized quantum machine learning frameworks through university collaboration. These are some of the tech giants come up, some of the quantum startups, and the government initiatives, national quantum initiatives. We also have our own quantum mission, which we discussed earlier, and also the universities in US, initiatives in US, EU, and China and India are funding joint industry academic projects with billions investments over the next decade. That's the plan till 2030, 2040. They have quite amazing plans in order to drive this quantum movement forward. And quantum machine learning, this is one of the just as of now, anyone can start this with, as I told you, QSkit is there, and whether it is a physicist, whether it is a computer specialist, or whether it is an electronic specialist or a material specialist, you need some simulation aspects. You need to run something, and you need to understand what in order to understand what's happening. It is easily possible as of now. It is easily possible. Some of the open source alignments are there available. Quantum learning, the convergence point. Quantum machine learning represents the intersection of quantum computing and artificial intelligence, offering exponential speeds for specific computational tasks. Definitely, you can realize, we just spoke about how this is happening. This will happen like that. This will happen in the faster speed. This will reduce the speed from 10 minutes to microseconds or milliseconds. This is possible. This you can realize through simulation. If possible, I can show that one simulation which I wouldn't able to show it properly earlier. I can show it. And quantum algorithm, variational quantum eigensolvers, and quantum approximate optimization algorithms form the foundation for quantum machine learning applications. Classical ML integration, hybrid quantum classical approaches leverage the strengths of both paradigms for enhanced performance in specific domain programs. Real world application, as we know that drug discovery, financial modeling, and optimization problem benefits from the quantum machine learning's ability to process a high dimensional data efficiently. And we know that because as data can be processed very fast, that's what definitely the future what we can foresee is the future with the space technology. We can see that there will be a pharmaceutical industry will have, because of the greater drug discovery. India will definitely have a pharmaceutical revolution in the future when we compare to any other countries. That's what we can foresee. The drug discovery, we have a lot of advancement going on in the drug discovery, and definitely this quantum computing can have an impact on the pharmaceutical industry. Leading pharmaceutical companies employ quantum sensors for molecular level analysis during a drug development. Quantum enhanced spectroscopy provides an unprecedented insights into molecular intersections, accelerating the identification of quantum therapeutic compounds and reduce development timelines up to 30%. That's what 30% with a real world application. Taking example of a drug discovery, there is a 30% reduction in the development timelines, and by identification of potential therapeutic compounds. Leading pharmaceutical companies they can employ this quantum technology, molecular level analysis during the drug development. That's what, with this technology and this adoption, definitely particularly in the drug discovery, particularly in the pharmaceutical space, India can impact a larger perspective. That's one opportunity. That's the one opportunity with the quantum technology, movement. And the next one is you can think of this is the chart. If you can think of global investment in quantum technology has reached unprecedented levels, with industry and the government funding driving collaborative research initiatives. There is a billions of, as we know that there is a gradual increase in the investment trends. That is a very much essential. You need to invest in infrastructure, you need to invest in the technology, you need to invest in the skill, you need to invest in the skilled talent, invest in the talent, you need to have collaborations, you need to have investments. These are the things are there, and the current research trends is very huge. It's a positive mode, it's in the positive mode. And again, strategic collaborative models. When you think of strategic collaboration models, these are all the things we discussed, and some of the things like intellectual IP sharing mechanisms, agreements. This is very essential when you talk about when you talk about the technology transfer, and the IP comes into a picture. Joint research center, shared facilities combining university expertise with industry resources and commercial objectives. Talent exchange programs. That's talent exchange program. As these are all running. As we know that these are all running, and they should run with this technology as well. PhD students, postdoctoral research working directly with the industry partners on a practical quantum ML application. Quantum application should be increased. This opportunity should be increased. But these are all the things are there, as well as there is a postdoctoral program in India as well as in overseas, where there are so many top 10 quantum universities which are all available, which are already available, and we need to have an exchange programs, and these programs are already there with the science and technology department. But in the quantum moment, again, we need to have a primary focus on this. And open source initiatives, collaborative development of quantum software frameworks and ML libraries accessible to the broader research community. Open source initiatives will give us most of the things. Like, say, we need not wait. When we have open source initiative, we can immediately start whatever we have preached. Preaching is different, practicing is different. Okay, whatever we have come across in the theoretical aspects, whatever we have spoken, that when in order to make that implementation, we need open source initiatives that will help us a lot. And IP sharing mechanism, there is each and every technology, it has its own framework and own structure for IP, intellectual property arrangements, that encourage innovation, whilst the protection commercial interest. While protecting our commercial interest, we need to have an IP sharing agreements when we have a collaborative research, collaborative opportunities, and collaborative work. Definitely, the IP sharing agreement should be in a harmonious way. Agreement should have a proper. We should have a proper mechanism so that there is a harmonious way. It should protect our primary. It should protect our primary interest. It should protect our research interest, discovery interest. It should also protect the commercial interest at a large. There should be a proper IP sharing mechanism. Flexible IP sharing mechanisms should be needed. And as we talked about talent exchange programs, there should be free flow of talent exchange program. There should be minimum rules. There should not be any barriers. That's all. Joint research centers, which are we have already sensed this in technology, semiconductor technology. We have sensed this in AI emission, and also in the future we should sense this joint research centers, IP sharing mechanism, knowledge exchange programs, and open source initiatives in the for the quantum revolution as well. And breakthrough application in the development, near-term applications and long-term prospects. We should think near-term quantum enhanced optimization for supply chain management, financial portfolio optimization using variation quantum algorithms, drug molecule simulation for pharmaceutical research. Pharmaceutical will have a greater edge in the future research in India. Definitely drug discovery is moving at a greater pace, and drug discovery pharmaceutical will have a greater revolution, particularly in Indian scenario. Material science application in battery and semiconductor design, and we are already in the forefront of these things. And then these are all some near-term applications. And when you think of a long-term prospectus, fault-tolerant quantum computers, general purpose machine learning, quantum neural networks with exponential capacity advantages, cryptography and cybersecurity application. As I said that the cybersecurity and the digital security of the nation, digital security of the individual at a smaller perspective, digital security at geographies, digital security at a large is very much expected, so that we should be sustainable. We should have a what we call it. We should be digitally secure, and we are relying on cryptographic so many keys, and we have spoken also. But when quantum, we also have a QSD, which is having a higher security mechanism, which is proposed to have a higher security mechanism that should work well for us. Quantum neural network with exponential capacity advantages, there should be a longer in order to look this application at a longer perspective. We need to have a very strong fault tolerant quantum computers for general purpose machine learning and quantum neural networks, cryptographic aspects, climate modeling and environmental simulations. We need to have a very very robust systems for a longer term prospectus. And challenges and research priorities, as we discussed earlier, the technical challenges, and this is the same which we declared in the global scale also. We saw the technical challenges. The technical challenges are same whether it is a global, whether it is our at a national level or a local level. The quantum error correction, decoherence mitigation, which I already spoken, coherence and decoherence mechanism in order to have a stable quantum extended quantum states, which can actually make a difference. And the quantum system to handle complex real world problems remain significant hurdles. Required sustained research investment is needed. Talent development, again the same thing. With the globally we spoke, we need to train. Some of the companies have come up in order to make the talent pool. Talent pool is very essential, otherwise there will be a very sluggish growth. In order to have a faster growth, we need to have a talent development. Talent pool is necessary. The quantum workforce strategies necessitates the comprehensive education programs bringing quantum physics, computer science, and machine learning. That is interdisciplinary. You need to promote as much as interdisciplinary approach. In order to have an interdisciplinary approach, then only it is possible. Product culture need to be accelerated. Product culture need to be developed in an academic level. You need to have that sort. A student with one product can make his life more better, or it changes anything else. A researcher which is having a one good product can change entire scenario, not only at the education level, not only at its institution, it may be at the national level as well. That's what a product can change. That the product culture should develop. That's what the main emphasis on talent development and standardization efforts, industry collaboration essential for developing quantum software standards, programming languages, benchmarking methodologies. Yeah, these are all very essential. There should be some standard programming languages. In spite of having n number of programming languages, there should be n number of standards. This should be as much as every day there should be a change every day in order to make things simpler. We right from the beginning we should have some formulation so that there are some standards are there and we can go with the standards, and setting some standards with the languages make things easier. Choices, giving much choices is an advantageous. Again, giving smaller choice is also another advantages in the initial stages. Later stages you can go with multiple choices. Ethical consideration, quantum computing impact on cryptography and data security requires proactive collaboration on quantum safe, secure protocols and responsible development practices. So these are some of the challenges and research priorities. And also the future research roadmap 2034 is foundation building, application building, scaling and integration, and establishing frameworks, improving quantum hardware stability, expanding industry academia partnership through joint research initiatives, and shared infrastructure development, application development, deploying quantum advantage application in specific domains, developing hybrid quantum classical algorithms, creating commercial quantum ML services for enterprise application. When you look into the enterprise application, we need to have a proper mechanisms. We need to have a proper advantages in deployment, advantages in specific domains. We need to think of scaling and integration, achieving a fault tolerant quantum computing milestone, and achieving the milestones, integrating quantum machine learning into mainstream AI workflows, establishing quantum computing a standard tool for complex optimization problems. And these are all this should be the roadmap in order to have a sustainable development. Shaping the tomorrow's quantum future, the convergence of industry collaboration and academic research in quantum computing and quantum machine learning represent one of the most significant technological opportunity of our generation. Strategic imperative: organization must invest quantum literacy, digital literacy. When new things came, digital literacy, and we thought about digital literacy, then came the AI corner and AI literacy. Now is the quantum literacy. Forage strategic partnership and contribute to collaborate ecosystem that will define quantum computing commercial viability. In order to have a viable commercial viability, in order to have a concrete strategic portfolio, in order to forge concrete partnerships, in order to have a collaborative ecosystem, in order to have a robust ecosystem, we need to have we need to invest in the quantum literacy, what you call it as a digital literacy, quantum literacy, or digital literacy. Quantum digital literacy is very much essential. That can be achieved through strategic imperativeness and call for action. The quantum revolution requires unprecedented collaboration between industry and academia and government to unlock transformative applications that will reshape entire industries. Success in quantum computing and quantum machine learning will be determined not only by individual breakthroughs, but by our collective ability to collaborate, innovate, and translate quantum advantages to practical solutions for humanity's greatest challenges. In order to solve humanity's greatest challenges, collaborative, innovative, and translate quantum advantages are essential. And thanks for making an opportunity. And thank you very much. And that's I'm going to. This is the end of my session.
Okay. Thank you, sir. Any questions from the participants? Okay. Hope there are no questions from the participants. So, on behalf of the management, the principal, all the HODs, teaching and non-teaching staff of Sridevi Institute of Engineering and Technology, Tumkuru, I would like to thank once again Dr. Rakesh L, Director, ATAL FDP Software Private Limited, Bangalore, for delivering a brief note on industry, collaboration, and future research in the field of quantum technology. Once again, I would like to thank you, sir, for being with us in spite of your busy schedule.
Thank you very much. Thank you very much. Thank you very much.
Thank you, sir. I thank all the participants for all your active participation. Now we are heading to the last session of the FDP. In this regard, I would like to welcome our expert, Karthik Ganesh Durai, founder and CEO, Quantum G Research Labs, Private Limited, Bangalore, to address one and all in this session.
Very good
Karthik
evening
Ganesh,
to all.
thank you, sir.
Thanks for the. Yes, sir.
Sir, you can continue, sir.
Okay, I think someone has to
Yes, sir. Yes, sir.
meet their mic. Okay.
Yes.
So today topic is industry collaboration on quantum technology. Now, as a different approach.
Sir, it is muted, sir. Karthik Ganesh, sir.
Oh, sorry, I'm speaking
Okay,
with
sir.
mic muted.
Okay, sir. Okay, sir. Thank you, sir.
I was telling thanks to SIT college and management and then staff and who are organizing this one, Shiv Kumar sir and then Kumar sir and Sri Kumar sir and Rajeshri madam and other faculty members of SIT. Then I was telling the today's session is not a PPT driven session. It is a discussion driven session. So the reason why it is organized as a discussion. Sorry, sir. Kiran, sir.
No, sir. No, sir. You can continue, sir.
Oh, okay, okay. Sorry, sir. I think
Okay,
you
sir,
are asking
thank you.
something.
Yeah.
So, the approach is going. I'm going to give you few websites where you can collect a lot of informations related to industry institute integration, particularly in quantum technology. But before sharing those websites, I want to ask a few questions. Let me share my screen and notepad, and I will ask a few questions. You can think through that one. I just visited our previous session, ATAL Lovelace website. It's really amazing because ATAL Lovelace is the first software developer. So I just wanted to know their services, and then it was really interesting. Right. The first thing, there are 73 members here. Out of 73 members, how many members are interested in business perspective of quantum technology? Maybe 30%. Remaining 70%, we are focusing on 30% focusing on business and strategy perspective. Let me increase this one, please. As I told you, the whole session is going to be notepad. But there will be a lot of websites I'm going to show as part of this industry collaboration. Then 70% are focusing on technology. Am I right? If I'm wrong, let me know, because but you can also someone cannot point out because we are not in the same place. It is not an in-person session. If it is an in-person session, all of us in a room, then we know who are focusing on strategy and business, who are all focusing on technology. Then we can easily debate the percentage, 30% or 70%. But based on my observation and experience of conducting many FDPs, and particularly FDPs conducted by technology organization or technology engineering colleges. This is the ratio. 30% are focusing on business strategy and perspective. 70% are focusing on technology. When it comes to the technology focus, see, this is, you can perform an introspective analysis. How are you viewing quantum computing as an industry? Most of us are viewing that as a research opportunity, not as an industry. But people who are staying in the industry for longer period of time, maybe more than 1 decade or more than 15 years, we know what are the opportunities as an industry. So that is the challenge if you are focusing on technology. If your focus is on technology, you will think that, or you will see only R&D opportunities. Am I right or not? Since 80% or 60% of the faculties who are attending this particular FDP, they might have heard the word quantum computing 12 months or the past 1 year only. Remaining maybe 40%, let us assume that 40%. They may know 3 years or 5 years. Their knowledge or their, how to say, they came to know through some channel there is something called quantum computing is going to come, like that only. And I don't believe anyone in this FDP's around 74 member having more than 5 years exposure to this industry. If anyone is there, please voluntarily come forward and then unmute and then please address, because your knowledge is very, very important for all of us. Anyone who is focusing or who is observing this quantum computing as a research R&D as well as business or industry? Anyone? Or you can type in the chat window also. So my question is, anyone observing quantum industry for more than 5 years? That is the question. If anyone is there, please answer. So I believe most of you are seeing my screen. Okay. I will wait for another 1 or 2 minutes. Oh, there is one answer. Oh, okay. No. Thanks, madam. Thanks for responding. That is amazing. Okay, right. No problem. It's not an issue because that's what I expected. And it is not a surprising to me because this industry is in the nascent stage, even though it is more than 40 years old technology. Now only it is started emerging as a industry. The transition made particularly for the past 7 years. Prior to 7 years, it was not at all considered as a market or industry. It was considered as a R&D. We used to call that lab to road. There is a what is called idioms and phrases kind of thing. For a technology, we use the word lab to road. When we say lab to road, the technology matured. There are some product came and people started buying. That is what lab to road. The period from lab to road for quantum technology is 40 years. And if you think about semiconductor, it is very short period. But if you see any other technology, for example, steam engine or electrical engine or mechanical innovation, all those things, they have their own 100 years, 200 years like that. But in recent days, quantum technology is one thing which came to road in a short span of time. Now you may be interested, okay, what are those short span of time? What are the achievements? That's for first time going to start the website called the Quantum Insider. Go to this website, the Quantum Insider. I will share this link in the chat window. Very important website. Right. Can you go to, if you are logging in mobile phone or somewhat you want to explore on your own, you can go. But don't worry, I'm going to walk through this website and give you what are the things you can find in this website. There are many website organization specific websites, all those things. But one thing what I am using for longer period of time, this quantum insider, TQI, the quantum insider, TQI. Here, this get access is a very interesting part. They have the subscription model, meaning that for academics, you can get free access, but you have to give a justification. And here the news you can see capital market, national quantum computing business research. This is what I want to focus. Quantum computing business. Okay. Now, the technical people or the technical faculty or technical students, they never worried about business. Fortunately, I am a different combination because I am a software engineer having a IIM Bangalore, and also I am an IIM Bangalore alumni. Now you understood. I am from B school, but I'm a software engineer and data scientist now working on quantum. So predominantly my roles are technology, but by qualification I have MCA, MBA, and B school executive MBA. So this kind of combination made me to think through business perspective. Now you realize why I selected this topic, because I'm seeing the potential in business. Now you may ask, KG, our topic is industry collaboration, but why are you talking about the business? I believe that you understand the connection, but I'm going to come to the connection soon. In another 8 minutes, I will come to the connection. Now I want to establish the importance of quantum computing business and the updated knowledge on quantum computing business. For example, most recently, an Indian organization got around 5 million seed funding. And there is another Indian startup which is based out of Kollam, Kerala. They got some considerable amount of seed funding. I don't want to announce the amount and all, but that company name is block.in. The founder is one of my well-wisher and then great friend, Sri Kutan. So that idea, see, in big companies in India, in quantum domain like QPI AI, QNU Labs, they are well established, even though they are startup, but they are well established. But there are small players who are entering, like me. I'm also a small player in this one, but have a good connection in the industry. And that helps me to understand what are the future or what are the help we need from institutes like you. We are hardcore business people and implementation engineers. For example, if we give you a problem, we will build the solution and hand over to you, collect the money, charge you, collect the money, move on to the next business. That is how industry works. But for as part of the work, if we have to do some research, our team member are not comfortable doing research. The reason is that we want the result yesterday, not today, not tomorrow. Business people or industry people always tell that I want the solution yesterday, meaning that you are already late. But researchers need an environment which is conducive to perform research with a sufficient time, because it is a trial and error. We don't know what is going to come out of this research initiative. So researcher working style, time availability, resource allocation are different, but industry is different. But industry needs researcher help because we know some approach what time tested. Based on that, we are providing the solution. It is like rotating square wheel, telling that I don't have time to invent or innovate circular wheel. You got the point, right? You know that there are a lot of WhatsApp memes. People are pushing or carrying by hand. When someone is helping with a wheel-based movement, they will tell, no, I'm busy. I cannot look into that one. But if they spend some time look into that one, they would have done that efficiently. Am I right? That is what predominantly happening in the quantum industry. We industry people, of course, we have a R&D team. Even our company is an R&D team. We have an R&D team. But as a founder, my focus is to building customer. So when can I confidently build my customer? When I know the technology, what I'm building is time tested. It is going to perform as expected, no surprises. But any R&D based outcome, it is always surprises. We don't know what is going wrong. So that is the challenge. We need industry people to build the solution, academia to do the R&D. So this is the entry point for the opportunities for institutes to collaborate with the industry. So that now you have to decide what research we can do. So you can wait for some company come to your college and talk to your industry, industry institute integration, what is called the industry collaborator or placement officer, telling that we are looking for 2 interns supported by faculty to perform a quantum communication research. You can wait. Or proactively, you can come to this Quantum Insider website, understand what is happening in the business. Then you can compare, is there, for example, Q4X and Rigetti awarded 5.8 million. Now if you know what is Rigetti, you will recall Rigetti is a superconducting quantum computer. Then you can connect, is there any cryogenic or cryo-based engineers in India? Because for superconducting, cryo engineers have a huge demand. So you can connect. Then if it is interesting to you, meaning that you want to work on a cryo, then you can connect with the Indian player or international player. So this will give you the huge demand because this is 2 days news. You see September 18. 2 days old news, this one. Rigetti awarded 5.8 million funding, which means in another 2-3 months, Rigetti is going to spend some money for their research expansion. And similarly, you see marine biologists partner with molecular, that actually each one is news. If you click that one, you can see the detailed news. So now you may ask me a question, KG, we are all hardcore engineering faculties, but these things looks like business news. We are not confident that we can understand the strategy. We can infer something from this one. If you are thinking that way, you are not wrong. And thinking that way, I would personally tell it is a smart thought process, because you know what is your strength and you also know what is your weakness. In that case, I strongly recommend approach commerce group in your college. Most of the colleges are your see, engineering college may have MBA. So approach the MBA department, get their help. Can you track this industry from the quantum insider? Try to identify any potential opportunity for the next year. This is very, very important. The quantum insider opportunity is not for today or this month. That is the important point you have to remember. I am recommending the quantum insider to identify the industry collaboration for 6 months or 1 year, not now. Why I am telling this way? Why anyone has an idea why I am telling this way? Come here, identify, but stay for 6 months. Why I am telling? Anyone able to understand why I am telling a 6 months period? If anyone have an idea, please type in the chat window. I am typing the question. Finding a potential collaboration, industry collaboration, okay? Industry collaboration from EQI will need 6 months. Minimum, will need minimum 6 months. Why? Any vast change will take minimum 6 months. That is one reason, okay? Meaning that the trend trend may take 2 quarters. That is what you are telling. Another reason is that building the network. You need to build a network with that company, because immediately you cannot go and connect with Rigetti or any other company. You need to identify the right person in that organization who is going to be interested in your paper and adoption planning. Yes, that is why that it will need minimum 6 months. Those things can researcher do, because researcher is focusing on the technology. For example, if you are a quantum communication or quantum cryptography or quantum machine learning or quantum optimization, quantum simulation expert, you have to spend your energy and put forth your efforts on your technology research. Now, who is going to build the network? And you are not, your skill set is research. So that is where I told, identify a commerce or business faculty to work with you. What is their roles? Networking, strategy, business growth, requirement gathering, communication, project management. So these are all the things what engineers cannot focus yet, but need to focus on practical implementation for academicians like us to collaboration. Yeah, that's what I'm going to come in another 3 minutes. I'm going to explain the practical implementation. What are the practical implementations you are having? But you may ask, but KG, that is what we are looking for. Why are you wasting our time? It is almost 17 minutes. You are telling some story. Believe me, as I told you, I am from B school, business school. And technical people should have a strategy. Handing over these things to business people, they will take care of that one. You can focus on the practical implementation. So, but you should know this one. If you don't know this one, you will not build a strong growth team. You will start working on practical implementation. Then how will you sell it? Without the potential buyer, who is going to build the network with the potential buyer? This particular approach, what I'm recommending, most of you may not like it, because going to an MBA department, if there is no MBA department in your college, you have to worry about who is that MBA department. We don't have MBA department in our college. Then you have to identify any non-technical person who is good at business strategy within your team. Some faculty may have that business potential. So you have to identify them. What at the end of the day, my suggestion is that you do the research, nothing wrong in it. You do the practical implementation, nothing wrong in it. But allocate the business growth and building the network, identifying the potential customer to some other team. They have to parallelly work with you. If no such a connection is established, industry collaboration very challenging. That is where most of the institutions are facing the issue now, because whenever I'm going and connecting with, because I have the privilege, since I'm talking about the quantum computing, faculties used to talk to me about, I want to publish a paper. Then I asked, what is your problem? What is your problem? We can find out some QML model. No, that is not the problem. QML model is the solution, but what is the problem? Then they will think, KG, what are you asking by means of problem? Then I used to tell, whether are you building optimization problem for logistics or supply chain management or any other cubo problem or higher order differential equation problem. Code, implement it, publish a paper. That is not the correct way. First, you have to identify some industry problem, practical